Assalamu alaikum wa rahmatullah. What's going on, guys? Welcome to Amigos Code. Today I'm super excited. As you can see, I'm super excited because I'm doing a collaboration with Nana from Techworld with Nana. Nana, go ahead and say hi to the community. So Nana, she's got a YouTube channel called Techworld with Nana where she provides awesome content on DevOps. And because I've got a course on Docker and she's really good explaining Kubernetes content, we've decided to collab and put a full course just for you. So this is everything that you need in order to get started with Docker and Kubernetes. So if you are not part of the Amigos Code community, go ahead and join now. There are over 8,000 people. Also subscribe to Nana's channel. The link will be in the description of this video. And if you haven't smash the like button, please smash it right now because it helps us to keep on providing content like this.
Thank you, Nelson, for your introduction. I'm also very excited to teach this course together with you. If you guys have any questions during the course or after the course, or you want to simply stay in touch, I would love to connect with you on social media. So be sure to follow me there as well.
Without further ado, let's go ahead and learn about Docker and Kubernetes. Right, before we kick off this course, what I want to tell you is that you should be practicing as we explain. So as Nana and I explain, you should be practicing because there is no point of view just watching the videos and do nothing, right? So Docker and Kubernetes are really awesome technologies, and the way that you're going to learn them is by practicing. Please practice. Also, if you have questions, feel free to contact us. And the easiest way is actually to be part of the community because the community is so engaging and you can ask questions. Everyone will be there to help you. And also you can share your expertise. This is all I wanted to say before we kick off this course. Next, Nana and I will give you an overview of this course. To kick off this course, we're going to start with Docker, and we're going to take a website as well as an API that we will build and then use Docker to package up things into images and then run containers. So you'll see how Docker works. So Docker just simply makes it easy for you to take whatever you build locally and then run it onto a server that has the Docker runtime environment, right? So if it works on your machine, it will also work on this server or anywhere that has the Docker runtime environment. And we're going to cover pretty much all the concepts that you need in order to use Docker with full confidence. Then after we understand exactly images and containers, right? Then we need a way of taking those containers and run it somewhere where those containers can be orchestrated for us. And this is when Kubernetes comes into play. So let me actually pass it to Nana so that she explains exactly what she's going to be teaching you and what is Kubernetes.
When you learn containers and Docker specifically, you can now start building complex applications with tens or even hundreds of containers that talk to each other or interact in some way. And of course, these containers would need to be deployed across multiple servers in a distributed way. So you can imagine the overhead and effort you would have if you had to manage these hundreds of containers manually with little automation. Every time the containers crash or the communication between them across the servers isn't working, you would have to manually interfere and fix these problems. So it would be great to have a tool that would automatically detect these problems and fix these issues itself to recover the application state. And that is the container orchestration tool. And Kubernetes is currently the most popular container orchestration tool out there.
Thanks, Nana. That was an awesome explanation about Kubernetes. Without further ado, let's go ahead and start our journey learning Docker and Kubernetes. All right, let's go ahead and understand what exactly is Docker. So Docker is a tool for running application in an isolated environment. So it's very similar to a virtual machine, but it's much faster and doesn't require a lot of memory and an entire operating system to operate. The cool thing about Docker is that your app runs in the exact same environment. If it works on my machine, it will definitely work on your machine. If it works on the staging environment, it will also work in the production environment. So this is one of the benefits of Docker. And pretty much it just works, right? If it works on my machine, then you are guaranteed that whatever you deploy your application, it will also work. And Docker nowadays is the standard for software deployment. Pretty much everyone is adopting Docker in their workflow for software deployment because it makes it easier for packaging applications. You don't have to deal with different OS, different distributions, and pretty much whatever you package will work in production. So pretty much almost every company is adopting Docker, and you should be aware of how to use this tool as well. So what exactly is the difference between containers and virtual machines? So a container is an abstraction at the app layer that packages your code and dependencies together. Multiple containers can run on the same machine and share the OS kernel with other containers, and each running as an isolated process in user space. So this is very important because a container doesn't require a full operating system, and it simply shares the underlying operating system but running in isolation of other containers. In contrast with virtual machines, is an abstraction of physical hardware turning one server into many servers. The hypervisor allows multiple VMs to run on a single machine. Each includes a full copy of an operating system. This is very important, a full copy of an operating system. Also, the application, necessary binaries and libraries taking up tens of gigabytes. And also they are very slow to boot. So just let me show you exactly a visual diagram. So this is a containerized application. So you can see that you have multiple apps. Underneath you have Docker and nothing else. So Docker manages all of the containers that you spin up. And underneath Docker you have the host operating system, and then you have the actual infrastructure. In contrast with a virtual machine, you can see that you have the infrastructure. On top of that, you have the hypervisor, and this allows one server to be turned into multiple servers. And you can see that each virtual machine requires a full guest operating system. So this is the fundamental difference between Docker and virtual machines. So the benefits of using Docker is that you can run a container in seconds instead of minutes. As you see that for you to spin up a full operating system, it takes a while. Also, less resources results in less disk space as well as less memory. So these are very good advantages of using Docker instead of virtual machine. And as I mentioned, you don't need a full operating system. So these are some of the advantages of using Docker, but obviously you have things such as deployment and testing. So you can test things locally and then you can take it to whatever environment and it is absolutely guaranteed to work. If you have any questions, go ahead and drop me a message. Otherwise, let's move on and learn how to install Docker. All right, let's go ahead and learn exactly how to download and install Docker. Navigate to docs.docker.com/install. So right here, you can see that you can download Docker for Linux, Mac OS, and Windows. So the process is the exact same thing whether you are on Windows or Mac. So because I'm on a Mac, let me go ahead and show you exactly how to get it for Mac. But for Windows, it's the exact same thing. I'm going to show you in a second. So go ahead and click on Mac OS. And then you can see that to download Docker for Mac, head to docker.hub. So what I'm going to do is press Command and click on the link. And then right here, you can see that I can get started with Docker. So what I need to do first, so to download Docker Desktop, so this is what we need, is to pretty much create an account or sign in. And once you have the account, you will be able to install Docker. The process is very straightforward. So you can see the requirements. So Mac OS Sierra 10.12 or above. So if you are using a previous version, you need to download Docker Toolbox. So Docker Toolbox is the old way of using Docker, and Docker Desktop is the newest and better way of working with Docker. So let me go ahead and pretty much show you exactly how it works, or actually how it's downloaded. So you can see that they have a screenshot. So basically, once you have an account, then you'll be able to download Docker. So basically, you take this docker.app, put it into your applications, and then you'll see that you have Docker. And then at the very top on your toolbar, you can see that you'll get a Docker logo. So this logo right here, and you can see that it will say Docker is up and running. And you can see right here in my machine, because I already have Docker installed, you can see that Docker is up and running. So it's very straightforward to get started with Docker. So for Windows, it's pretty much the same thing. So what I'm going to do is collapse this, click on Windows, install Docker on Windows, and you can see that it's the exact same thing. So download from Docker Hub, there we go, it's the exact same thing. So please log into download, and then once you have it downloaded, you can follow these instructions right here. But basically, it's the exact same thing here. So if I scroll down, you can see that you have Docker for Windows. You will also get the actual Docker logo, and then you'll see that Docker is now up and running, which is the exact same thing that I have here. So go ahead and download Docker Desktop for whatever operating system that you are using. And if you have any questions or if you get stuck, go ahead and drop me a message, but this should be very straightforward. In the meantime, join me in the next one. Now that we have Docker installed, go ahead and click on this Docker logo icon at the very top, and you can see that we have a couple of options right here. So we have preferences, updates, documentation, more of Docker, sign in, and Kubernetes. So what I want you to do first is to open up your terminal or command line and simply type Docker. And you should see that you get a bunch of commands. So you can see that you get a bunch of stuff really. So options and then management commands. And you can see all of these commands that we will learn in this course. So you saw that you can type Docker, but also if I go ahead and type Docker -- and then version, you can see that this is the version of Docker that I have installed on my machine. This might be a bit different for you, but the commands will be the exact same thing. So what I want you to bear in mind is that if I click on the Docker logo again, and then quit Docker Desktop, and then type Docker, and for now, simply go ahead and type Docker PS. You can see that cannot connect to Docker daemon right here. So the Docker daemon is not running. So whenever you are using Docker, make sure that the actual Docker daemon is running. So let me go ahead and simply run it again. And let me skip this version. And you can see that it's starting. Just give it a second. You can see that it's starting right here. And there we go. You can see that it's green. If I now go back to terminal and type docker ps, you can see that this time it works, right? So just to bear in mind that whenever you want to use Docker, you have to make sure that the Docker daemon is running. And there we go. You now have successfully installed Docker and know how to get it up and running. Let's begin our journey in learning Docker. Let's begin our journey learning this awesome technology called Docker. All right, let's go ahead and learn about Docker images and containers. So an image is a template for creating an environment of your choice. This could be a database, a web application, an app that does some processing. Pretty much it could be anything. An image is also a snapshot, and you'll learn more about this. But basically, you can create multiple snapshots, i.e. versions of your image, and then you can point to whatever version that you want at a particular time. So let's say that you deploy to production an image, you find out an error, and what you can do is simply go back to the previous image. What is so special about an image is that it contains everything your app needs to run. It contains the operating system, any software required, as well as the application code. So once you have an image, then containers come into play. So a container is simply a running instance of an image. So what you do first is you have an image, and then from that image, you simply run a container. Let's go ahead and download an existing image and run a container from it. All right, let's go ahead and pull an image and run a container from it. So navigate to hub.docker.com, and right here you can see a list of all public images. So right here, so you can see that if I scroll down, you have a list of official images. So these are companies, for example, such as NGINX, Mongo, Node, Redis, Ubuntu, Couchbase, Golang. So there are tons of these official images that we can use, but also there are some unofficial images. So these would be, for example, someone like yourself or I that don't necessarily own a large company, but we just build images for other developers to use. So we could also distribute these images inside of this Docker registry. So Docker Hub is simply a registry, and we're going to learn more about registries later on, but a registry is simply a place where you can download images. So you can see that I can explore some images. So let me go ahead and simply explore, and you can see that there are tons of these images, right? So I can scroll down, and the list is endless. So the one that I want to try out with you is this one, NGINX. So what I'm going to do is, if you don't see this image right here, so NGINX, so scroll up, and right here simply type NGINX. So I always get this wrong. So NGINX, just like that. So I always get this name wrong. So NGINX is simply a web server, a reverse proxy, a load balancer, and it's very popular and it's used all over the internet. So if I scroll down, you can see that they have some tags, and we're going to learn about tags later on. Dockerfile as well. Later on, we will learn about this. And they have some quick reference. So what is NGINX and how to use this image. So let's actually scroll up, and you can see that they have this command right here. So docker pull and then NGINX. And let's go ahead and pull this image. So let me go ahead and open up terminal, or you can use command line if you are on Windows. So let's simply go ahead and say docker and then pull and then NGINX, just like that, and then press enter, and you can see that it's using a default tag, and it's actually downloading NGINX for us. So just give it a second, and I'm going to explain all of this later on. But basically, if this image changes, it doesn't have to download every single layer again, so it is cached. There we go, and you can see that it has downloaded a newer image for NGINX and then column latest. So this part right here is the actual tag, and we're going to learn about tags later on. But basically, this is simply getting the latest image. Now, in order for us to see a list of images that we have locally, simply go ahead and type docker and then images. And there we go. So you can see that the image that we have currently is this one. So we only have one image, and the name is NGINX. The tag is latest. This is the image ID, and you can see that it was created about 3 days ago, and the size is 109 megabytes. There we go. You successfully managed to pull your very first Docker image. Next, let's go ahead and run a container from this image. Let's go ahead and run a container from this image that we've just downloaded. So NGINX, and then the tag is latest. So remember, a container is a running instance of an image. So to run a container from an image, simply type docker and then run, and then we have to specify the actual image. So in our case will be NGINX, and then you have to specify the tag. So in our case, latest. So if I press enter, you can see that we get nothing. So believe me or not, but we are actually running a container. So the reason why this is hanging, because the process has started and is just waiting. So what I'm going to do is open up a new tab, and inside of this tab, what I'm going to do is first, let me actually make this bigger, and so something like that, so you can see exactly what we're doing. So what I'm going to do now is describe the list of all running containers. To do that, simply type docker and then container and then ls. Press enter. You can see that we have this container with an ID of 83910ABD360C, and then the image is NGINX latest. You can see some commands created about a minute ago. The status is up about a minute, and you can see that the ports, it's 80. So 80, I'm going to explain the port in a second. And the name is Happy Volhard. So I'm going to explain this bit in a second. So this port right here, because it's very important for us. But you can see that we have an image up and running. So go back to the other tab, and you can see that right here. So this is actually a bit bigger now, but basically the process is hanging right here. So what I'm going to do is simply cancel out of this. So Control C. There we go. I'm going to clear the screen there. And right here, simply type docker container and then ls. And you can see that the container is no longer up and running. So the same here. So remember, this was a container. So docker container ls. You can see that nothing is up and running. So what I'm going to do now is close this tab. And I'm going to run the container. So docker run nginx latest. But now what I'm going to do is add a flag. So minus and then D. So this simply says run this container in detached mode. So if I press enter, you can see that the process is no longer hanging. So it's running in detached mode. And then we get this ID right here. So now we can view the list of all containers running. So docker and then container and then ls. Enter. You can see that this is our container, which is up and running 18 seconds ago. So let me go ahead and clear the screen. Another way that you can check the list of running containers is simply type docker and then ps. So this is the preferred way and much faster. Enter, and you can see that we get the same thing. And now you can see everything is the same apart from the actual name right here. So Suspicious Snyder. And the port is the same. So this port right here I'm going to explain next, but this is very important for us to understand. So 80 and then TCP. And there we go. So you successfully managed to run your very first container by running docker run -d in detached mode, and then the name of the actual container. So NGINX and then latest. Next, let's go ahead and learn exactly how we're going to be able to use the container. So far we have our host, which has Docker running. So we are running Docker in our computer. And right now we have one single container, which is running NGINX. And this container is exposing a TCP port, and the port is 80. So let me show you exactly this again. So right here, you can see that we have ports and then 80 and then /TCP. So what we want to be able to do is from the host, we want to issue a request to our container, which is exposing port 80. So we want to be able to go to our web browser, type localhost 8080, and then that port 8080 should be mapped to port 80 on the container. So basically we want to go from the host to the container. And the way that we achieve this is simply by adding -p before we run the container. So -p 8080 from the host should be mapped on port 80 on the container. And then we'll be able to access the application running from within the container. So let's go ahead and open up terminal or command line. And what I'm going to do first is stop this container. So to stop a container, simply type docker and then stop and then pass the container ID. So I'm going to command C that, command V, and then enter. And you can see that the container has stopped. So if I type docker ps, you can see that nothing is running. Let me clear the screen. So I'm going to issue the same command. So docker run -d or -d. And then let's go ahead and say dash and then p. And we want to go from the host. So whenever we type localhost 8080, we want that to be mapped to port 80 on the container. So press enter, and you can see that the container is up and running, docker ps, and there we go. So now you can see that the ports is a bit different. So you can see that right here, we are simply saying map localhost 8080 to port 80 inside of the container. Now let's go ahead and open up any web browser and then simply type localhost and then column 8080 and then enter. And there you go. So you can see that we have this welcome page that says welcome to NGINX. And there we go. So we've managed to map the host port 8080 to the container port 80. So let me go ahead and pretty much just stop this container. So docker and then stop and then pretty much just get the ID. There we go. If I now refresh, you can see that the site can't be reached. So we've mapped port 8080, but you could also map a different port. So let's go ahead and map port 3000. There we go. Now if I change this to port 3000, and you can see that it's working, but from a different port. We could also map both port 8080 and port 3000 to port 80 inside of the container. So let's go ahead and do that. So let me go ahead and simply stop the container. So I think this will be now a different container. So let me go ahead and simply say Docker and then PS, grab the ID, Docker stop. There we go. Clear the screen, Control L. Now, if you want to map more than one port, simply add another -p 8080 to port 80. Enter. Now, if I type Docker PS, you can see that right here, localhost 3000 maps to port 80 inside of the container, and localhost 8080 also maps to port 80 inside of the container. So let's go ahead and test this out. So if I refresh, this should work. So 3000 works, and now 8080, and this also works. There we go. You now know how to map ports from the host to containers. If you have any questions, go ahead and drop me a message. Otherwise, let's move on. Let's go ahead and learn exactly how to stop, remove, start, and name containers. So if I go ahead and type Docker PS, you can see that currently we have this container right here. So this is the ID, and it's mapping both port 3000 and 8080 to 80 inside of the container. So this is what we have currently, right? So this is the NGINX, localhost 8080, this works, and localhost 3000, this works. So the way that you stop containers is simply by saying Docker and then stop, and then you can pass the ID or the actual name. So let's go ahead and grab this name right here. So Command C, paste that in, and then enter, and you can see that we get the name back. Now if I check my web browser, refresh, you can see that it's not working because we stopped the container. Now an interesting thing is we've just stopped the container, but we haven't removed it, so the container is still available for us to start. So to start the container, simply grab the same name and say Docker start, and then the same name or the actual container ID. Enter. You can see that I get the name back. If I check my web browser, and there we go. So you can see that the page is working again. Now let me go ahead and stop this container. So it's Docker stop, and this time I pass the actual ID, and let me clear the screen for now. Refresh the web browser, you can see that it's not working. If I go back, so how do you know the list of containers that are not running? So if I type Docker PS, you can see that we have no containers right here. But indeed, what this command does, so Docker PS, it simply lists the running containers. So go ahead and type Docker and then PS --help. And right here you can see that you can pass some options. So -A for all, and you can see that the default shows just running, and you can do some filtering. You can do quiet, that displays only the numeric IDs, and you can check the size as well. So let me go ahead and simply clear the screen and type Docker PS and then A. And you can see that we have a couple of containers right here, and all of them are NGINX. So remember, up to now, we've actually stopped many containers and then we start them again. And whenever we start them, we simply got a different name. So you can see that this is a different name. This is a different name. The same here. And also the ID, right? We get a brand new container. So we've never reused existing containers. Now, how do we delete containers, right? So how do we delete containers? So to delete a container, so what you need to do is simply say docker and then rm, and now you can delete a container by the actual name or container ID. So let's grab this very first one right here, created 25 minutes ago, and you can see the name is Elastic Sanderson. Paste that in, enter, we get the actual container back. Now if I type docker and then ps -a, you can see that the container is gone. So if I remove that, and remember, I've actually searched before, so this is the actual ID that we removed, and you can see that it's no longer in this list. So just let me cancel out of that. You could also remove every single container in one single command. So you could say docker rm, and then you could say I want to delete that one, and then you'd say I want to delete this one as well, so docker rm. But you can see that it's a bit tedious. So what we can do is grab every single ID and then pass that into a command, and then we will delete everything. So the way we do it is simply, so if I clear the screen, so docker ps --help, you can see that we have this quiet, so display only numeric IDs. So let's go ahead and say docker ps - and then a, meaning that I want every single container, including the ones which are stopped, and then q for quiet, that gives me only the numeric IDs. If I press enter, you can see that I've got only 5. So if I want to remove all of these, I simply type docker and then rm and then press $, and within $, simply say docker ps -a and then q, right? So we're simply getting this command and passing it inside here, and this will remove every single container that we have. Now bear in mind that if you have a container that is running, this won't work. So let me first delete, and then you'll see it. So if I remove everything, you can see that I get every single ID back. Now if I type docker ps -a, you can see that we have no containers available. Now let me go ahead and start a container. So if I click screen, so let me search here, so 3000, and let me go ahead and start this container. There we go, docker ps, you can see that it's running. If I refresh the browser, there we go. Now if I go ahead and simply try and remove the container, right? So let's go ahead and run this exact same command, so docker rm, and then give me all the containers. So if I press enter, it says that you cannot remove a running container. Stop the container before attempting removal, or you can do a force rm. So the way that force rm works, so you simply pass -f, and it simply says that I really don't care whether it's running, I simply want to remove the container, and that's it. So if I press enter, you can see that that took a while, and I get the ID back. So if I refresh the page, you can see that we have no containers. Now if I do a docker ps, and there we go, docker ps -a, enter, and we have no containers available. If you have any questions on stopping, starting, and removing containers, go ahead and drop me a message. Next, let's go ahead and learn how to name containers. All right, let's go ahead and start a container. So simply type docker run -d -p and then expose whatever ports that you want, and then press enter. So if I type docker ps, you can see that we have a name right here. So elegant and then ride. So usually this is a random name that is given to you if you don't specify a name. But in reality, when you create your own containers, you should be giving them a name so that you don't rely on the ID nor the actual random name, right? So the way that you give a name to a container is simply by using dash dash and then name. So let's go ahead and simply stop this container. So Docker, actually, let's go ahead and force remove everything. So docker rm -f docker ps and then -aq, enter. There we go. So now let's go ahead and run the exact same command. So docker run -d. So what I'm going to do is go to the start, and then right here simply go ahead and type dash dash and then name, and now we can give this a name. So let's go ahead and simply say that this will be our website, right? So now if I press enter, you can see that the container is running. But if we type docker ps, you can see that now the name is website. And this makes your life much easier for you to identify your containers. And trust me, you should always name your containers, because most likely you'll be running multiple containers at the same time. So now I can simply go ahead and say docker stop and then website. And you can see that I don't have to rely on the actual container ID. I could use it, but because I've named my container, I can simply say stop my website, just like that. So if I press enter, you can see that stopped the website, and I can simply start it again. So docker start and then website. So there we go. You now know how to name containers. Let's go ahead and learn exactly how we're going to take docker ps and format this result right here. So you can see that sometimes it might be a bit difficult for you to read what's going on. So you can see that we have container ID, and then the ID it's right here, and then we have the status, and the status goes over to the next line, and then we have the image, and you can see that the ports, then it's, yeah, sometimes it's very difficult for you to read. Let's actually go ahead and start a second container. So docker and then run and then -d -p and then NGINX and then latest, and let me actually name this. So dash name and then website and then 2 and the port as well. So let's go ahead and simply map 9000 to port 80. So press enter. You can see that it's running. So if I do a docker ps now, you can see that I've got 2 containers up and running, and the output is it's even harder to read actually. So what we can do is simply use a format. So we can say docker ps and then minus format, and this is equal to, and what I'm going to do is simply copy some code right here, but basically this simply gives a label and then tab, and then right here it grabs the actual ID. The same with name and then names, image and then image, ports, so on and so forth. And you can get this entire line in the description of this video. So let me go ahead and simply Command C, go back, and what I'm going to do is simply paste that in, and this has to be within quotes. And if I now press enter, you can see that now the format is much nicer. So you can see that we have the ID, the name, image, port, command created, status, and basically it's much easier for you to read if you don't have enough room. So what I like to do with this is simply export to a variable. So format equals to, and then paste that again. Oh, actually, I need to paste this again. So copy and then paste that, enter. And now if I type docker ps, you can see that it's not formatted. And if I type docker ps dash dash and then format equals to $ and then format. So this is the name of the variable. So this $ format refers to this variable right here. So if I press enter, and let me do that again so you can see exactly nice and neat, and there we go. So you can see that it's formatted. And there we go. You now know how to format the results of Docker PS. Alright, in this section, let's go ahead and learn about Docker volumes. So Docker volumes allows us to share data. This could be files or folders. So you can see on the diagram that I have here that you have a container, and then you have the file system, and under that you have the Docker area. And through the container and the file system, you create a volume. So I'm going to show you exactly this in a second, how it works, but volume simply allows us to share data between host and container, and also between containers. So the way it works is that you have a container running on a host, and in our case we have an NGINX container. So one, we have to create the volume, and then this volume allows you to share data between the host and container, and vice versa. So let's say that we add a file in our host, in our machine. This file A will also appear in the actual container inside of the volume. The same by adding a file in the actual volume inside of the container, that will also appear in my host operating system. And the same is true with folders. So if you add a folder on your host, then that will also appear in the actual container. Let's go ahead and learn exactly how to share data between host and container. Alright, so go ahead and navigate to help.docker.com and search for NGINX. And right here, what I want to show you is exactly how we're going to be able to serve our own files during development with NGINX. So scroll down, and right here you can see that hosting some simple static content. And basically you can see that right here. So they give a name to this container, so some NGINX, and then -v, and then this is the actual volume. So this bit right here is the source, and this is the destination. So inside of the container, so this path right here, so user share NGINX and then HTML, inside of that folder we can share our own files. And if you are developing an application or a website, that's where you should put your files in. And then right here you can see that this is a read-only volume. So let's go ahead and pretty much create a file and then mount our directory inside of this folder so that we can override the default NGINX welcome page. So let me go ahead and open up terminal and docker run and then -- name. Let's go ahead and create a website. So I've deleted all the previous containers, and -p and then 8080 to 80, and then the actual container will be NGINX, and I can say .latest, or if I don't specify the actual tag, it will bring the latest by default. So if I run this, or actually let me actually add -d for detached, and then if I go to my web browser, refresh, you can see that's forbidden, and this is because this is 8080. And there we go, we have this default NGINX welcome page. In the next video, let's go ahead and override this default web page by simply mounting a volume from the host to the container. Alright, let's go ahead and create a volume between our host and our container. So inside of our desktop, so in the host machine, we will create a folder called website, and then we're going to have an index.html. So that file, or the contents inside of the website folder, will be shared inside of the container in the following directory. So users, share, NGINX, and then HTML. So that way, when we hit the URL in our web browser, we will be served with our own files. So let's go ahead and do that now. So right here, what I'm going to do is pretty much just open up VS Code and go ahead and open up your favorite IDE. But in my case, I'm going to open up VS Code. And then what I'm going to do is simply create a new file. And then in this file, let's simply go ahead and have an h1. So this will be some HTML. So h1, and then hello, Docker, and volumes. So we will have a better page, but for now, this will be enough. So now I'll go ahead and save this. Navigate to desktop. Inside, create a new folder. Name this as website. And then create. And then name this as index.html. Press enter. And there we go. Now what I'm going to do is start a container and mount the website folder to our container. So go ahead and open up terminal. And right here, let me simply say Docker and then stop and then website. There we go, Docker RM and then web and then site. There we go. So this is completely removed. So now let's go ahead and navigate to the website folder. So CD and then desktop. And there we go. And also CD into website. So if I do an ls, you can see that we have index.html. Now let's go ahead and start a container and then mount the entire folder to our container. So the way we do it is, let's go ahead and scroll up, or actually go up a couple of times. And now what we're going to do is, so pretty much after website, so after you name the container, go ahead and simply say dash and then V. And then right here, we can simply say $, and then within brackets, pwd. So this simply takes the present working directory. So let me actually show you. So let me cancel out of that. If I type pwd, I get the content. So this is what I get, right? So if I pass that, so I think on Windows, you simply say dir and you get the same thing. So let's go ahead and grab this again. And then what we're going to do is we're going to mount this folder called website to, and remember, so if I open up NGINX, you can see that this is the actual destination. So user, share, NGINX, HTML, and then you can say read only. So grab everything and then go back and then paste that in. And there we go. So now let's go ahead and press enter. And there we go. You can see that we have started a container. And if I now go to my web browser, and then remember before we had this welcome page, which was the default presented by NGINX. Now, if I refresh, you can see that we are serving our index.html. So let's go ahead and change that. So let me go ahead and simply say hello with volumes, and then let's simply say read and then only. Save this, go back, refresh, and you can see that the contents are mounted, right? So whenever we change the index.html, that is reflected in our container. So what I'm going to do now is I want to show you that if we have a file inside of the container, that will also appear in our host. So go ahead and simply type this docker and then exec and then -it and then simply say website and then bash. So this simply says that we want to execute this in interactive mode, pass the actual container, and then we want to execute the bash command. So if I press enter, you can see that now we are inside of the container. So if I type ls-al, you can see that this is the Linux file structure inside of our container. So remember, this is the running container. So now remember, we mounted user share NGINX HTML. So let's go ahead and navigate to that. So cd and then user share NGINX HTML. And then if I clear the screen, if I do an LA or actually ls-al, you can see that we have our index.html. Now let's go ahead and simply say touch and then about.html. And this is just a file with nothing inside. So if I press enter, you can see that this is a read-only volume, which means that the container can only read the contents. If it wants to write to it, it's impossible. So the way that you tackle that, so let's go ahead and exit this container. So Control and then D and then Docker PS. Let's go ahead and simply say Docker rm-f and then website. There we go. Now what I'm going to do is simply run the exact same container, but right here, instead of passing the read-only flag, I'm going to remove that. Enter. Now let's go ahead and bash into the container again. So docker exec -it website and then bash. Enter. cd to user and then share NGINX HTML. If I clear the screen, now if I do an ls, you can see that we have index.html. If I touch about.html, press enter, you can see that works. Now if I go to my desktop, and you can see that we have this folder right here called website. So I'm going to open it up, and you can see that we have the about.html right here. So from our container, this file also appears in our host. And you can see that this still works. And there we go. This is how you share files between the host and containers using volumes. All right, let's go ahead and customize our website. So this website right here, which simply says hello Docker and volumes. And by the way, that's not read only anymore. So let me go ahead and remove that. And if I visit the page again, refresh, you can see that hello Docker and volumes. So go ahead and navigate to Google and do a search on Bootstrap single page template. So go ahead and click on this very first link. So free Bootstrap 4 landing page themes. And right here, go ahead and pick any website of your choice. So what I'm going to do is pretty much just pick this one right here. So grayscale, and then click on view on GitHub. There we go. So now let's go ahead and simply clone or download. Let's go ahead and download the zip. Now open this in your desktop, and then let me unzip this. There we go. Delete the zip. And what I'm going to do is pretty much just take everything. So I'm going to take everything here, Command C, and then go to my website, and then let's delete everything and then paste. There we go. So you can see that we have this index.html, and we can go ahead and delete this folder. So Bootstrap grayscale master, delete that, and there we go. So now I'm inside of the container. So I'm going to do an ls -al. you can see that we have the files that we've just downloaded. So what I'm going to do now is simply visit the web page. So I'm going to close this and this as well, and go ahead to localhost 8080. Before we had hello docker and volumes. Now if I refresh, you can see that we have this awesome website. And feel free to make changes to this website according to your needs. So you can see that this works beautifully, right? So you can see that we have a nice, beautiful website. So I can click on projects. You can see that takes me to projects, contact, and there we go, right? So let me go in about, and you can see that it's built with Bootstrap, and you can see that it's working beautifully. And there we go. I just wanted to show you that you don't have to have a boring website as we had. So you can go ahead and build your own website and then deploy it with NGINX. All right, now let's go ahead and learn how to share volumes between containers. So we have a container A and we have a container B, and we can share a volume between them, i.e. we can share the contents of a folder or a file between these two containers. So let's go ahead and try that out. So currently we have this NGINX container named website, and it's serving our beautiful website. So you can see that running on localhost 8080. The way that we can share files or folders between containers is by using a command volumes from. So go ahead and type docker run -- help, and this will give you all the options that you can use with docker run. Enter, and you can see that at the very bottom you have volumes from. So -- volumes from, and then mount volumes from the specified container. So let's go ahead and clear this, and then docker ps. So let's go ahead and start a brand new container. So docker run, and then -- name. Let's go ahead and call website - copy, and then and then d minus and then p. So this will be 8081 to 80. So port 80 is already being used, so we have to map to a different port, and then go ahead and simply say NGINX. And right here, what we need to do is simply say volumes, right? Because we want to map a volume from this running container. So the way you do it is -- volumes -- and then from, and then you pass the actual name. So the name of the container is website. Now let's go ahead and press enter, and you can see that it's up and running. Docker, or actually let me press up 2 times, clear the screen. You can see that we have 2 containers running. One container is available through 8081, so that's the port, and this is the website copy, and the website is through our 8080 port. So let's go ahead and give that a go. So open up your web browser. So 8080, so this is the main website. So refresh, you can see that this still works. Now if I go ahead and hit the 8081, which is the website copy container, and we shared all the contents from the website container to the website copy container, this container should have the exact same website. So if I press enter, you can see that still works. So we've managed to share data across these 2 containers. All right, in this section, let's go ahead and learn exactly how to use Dockerfile to build our own images. So far, we've been using existing images, i.e. the NGINX image, and from that, we've been running containers. So what a Dockerfile allows us to do, it allows us to create our own images by creating a file called Dockerfile. And this file simply contains a list of steps of how to create images. And then we can run images built from Docker files as we've been running existing images. Let me go ahead and show you the documentation that you need when building Docker images. Alright, so right here, this is the Dockerfile reference. So in this page, you can find every single command that you can use when building images. So as I mentioned before, Dockerfile, it's simply a series of steps that defines how your image is built. So in this page right here, you can see that they have quite a lot of things, but if I scroll down, you can see that they have stuff with environment replacement, dockerignore, and then the from keyword. So every single Dockerfile has to have this from keyword. So I'm going to explain this in a second. And then you have the run command, and then you have the cmd command. You've got label, you've got expose, you've got add, you've got copy, entry point, you've got args. You've got a bunch of these commands that allows you to build Docker images. Let's go ahead and create our very first Docker file and then create an image from it. All right, let's go ahead and take this beautiful website and build an image using a Docker file. And then we can pretty much run as many containers that we want from our custom image. So far, we've been mounting a volume. So if I show you exactly what we've been doing. So right here in this command, so we've been mounting a volume from the host to the container. So this is why you can see this beautiful website. So we are taking all the index.html, all the JavaScript, pretty much. So if I do an ls here, or actually ll, so you can see that we have a bunch of things. So we have CSS, images, JS, vendor. So basically we have everything, and then we mount a volume inside the container, and then we are able to view this awesome website like this. So this is really good for development purposes. So you want to mount a volume when you are doing stuff in development, but when you want to build a custom image, you don't need to mount a volume from your host to the actual container. So what you ought to do is to copy. So you want to copy everything into your image, right? So when you're actually defining how you want to create an image, you ought to copy this so that you don't have to mount a volume. So let's go ahead and learn exactly how to do that and then run a container from it. So what I'm going to do here, so I want to pretty much just say Docker, and then let me clear that. So I just press Ctrl L, image, and then ls, and you can see that we have the NGINX image. So this is the latest tag, and that's the one that we've been using so far. And I've gone ahead and deleted all the previous containers, and I'm only left with one container, which is running our website. So Docker PS, or actually let me format this, so like that. So you can see that, so that and that. So you can see that we have one image, and we also have one container, which is running based off this image. So what we want to do now is create our custom image and then run a container from it. So right here, we don't need to mount a volume anymore if we are building our own image that contains everything. And remember, images should contain everything that your application needs to run. So it should contain all the dependencies, all the source code, pretty much everything that your application needs to run. And that's what we're going to do now. So go ahead and open up VS Code or any IDE and open up the website folder. So inside of this website folder, let's go ahead and create a Docker and then file. So this must be named as Dockerfile, and make sure that this is inside of the root folder. So inside of the website folder. So right here, the very first command that we're going to learn is the from keyword. So from keyword is the name of the base image that we want to use. So usually when you build your own images, you will never build an image from scratch. You will always use an existing image as your base image and then produce your own image. So in our case, we want to use the NGINX and then column and then latest. So you've seen this already. So when we say docker run, we're running this image right here. So we want to build an image based off this image right here. So this image called NGINX. Now the second command that we're going to do is we're going to say add. So let's go ahead and say add and then simply say dot. And then we want to add everything in the current directory. So CSS, image, JavaScript, pretty much everything right here into a destination. And if you remember correctly, so the destination that we want to add is this one right here, right? So this is where the static content should live if you want to serve static content with NGINX. So let me go ahead and simply paste that in. So this is from, and then this is the actual destination. And let me go ahead and save this. And this is pretty much a very simple Docker file that will produce an image. Now that we have a Docker file, next, let's go ahead and learn how we're going to build an image from this Docker file. So go ahead and open up terminal or command line if you're on Windows, and make sure to navigate to the website. So right here, if I do an ls, or actually la, you can see that I have my Docker file right here. So the way that we build images from Dockerfile, it's simply by running this command. So we need to say docker and then build. So we want to build, and we have to specify few parameters. So at least we must specify the tagging. So how we want to tag this image. So go ahead and simply say dash dash tag, or simply dash and then t. So let me go ahead and say dash dash and then tag. And in fact, let me show you the commands. So docker build and then dash dash help. So here you can see the list of all the commands that you can use when building from a Docker file. So right here, so this is the one. So dash t or dash dash tag. So name, and optionally a tag in the name and then the actual tag. So this is the format, right? So let's go ahead and simply clear this. So let's go ahead and say docker and then build and then dash and then dash tag, so that you remember that dash t is dash dash tag. And then let's go ahead and give it a name. So the most obvious name is website. And then right here, let's simply go ahead and give this a tag. So the tag will be latest. And I'm going to show you exactly the best way of you tagging your images later on. But for now, let's simply go ahead and say that the name, right? So when you tag, you say that the first part is the name. So the name is website, and then the version is latest. So the same way that you saw with NGINX. So if I cancel out of this for now, so docker and then image and then ls. So right here, you can see that the name is NGINX and then the tag is latest. And the way that we refer to it is simply saying n and then GINX and then column latest. So we are doing the same thing for our own image. So let's go ahead. So let me go ahead and simply grab this and then clear the screen, Control L, paste that in. And then the last thing that you have to specify is where is your Docker file. So my Docker file is inside of this directory called website. So simply go ahead and add a dot. So this will look for a Docker file and then build an image from it. Now let's go ahead and press enter. And you can see that we have built an image. So you can see that right here we had two steps. So the from, so this is the actual line 1 right here. So this is the base image. And then you can see that we have the step 2, which simply added everything in the current directory to this destination inside of our container. And you can see that we have some random numbers here, and I'm going to explain this in a second. And you can see that we built an image and we successfully tagged it as website and then latest. Now, if I go ahead and simply say Docker image and then ls, and now you can see that we have two images, and this is our image. So you can see that the repository is website, the tag is latest, the image ID, so this is the image ID, which is this one right here. And you can see that it was created about a minute ago, and then the size of it is 135 megabytes. So there we go. Now that we have an image, let's go ahead and run a container from it. So let me go ahead and clear the screen and do a Docker PS format. And let me go ahead and simply stop this container. So Docker, or in fact, let me go ahead and remove this container. So Docker RM and then -f and then website. There we go. You can see that we have no containers running. There we go. Everything is empty. And let me actually see if we have any containers which are currently stopped. So Docker PS -a, and then you can see that everything is empty. That's fine. Now let's go ahead and pretty much just do a Docker and then image ls, and let's run a container based off this image right here called website. So let's go ahead and simply say Docker and then run --name. Let's give it a name, website. And then right here, let's simply say -p for the port. So this will be 8080 from the host to port 80 inside of the container. And then let's go ahead and also say that we want to run this in detached mode. So -d or -d. And finally, the image that we want is website and then column latest. And if I go ahead and press enter, you can see that we get this huge ID back. If I do a Docker PS, you can see that we have a container running, and it's running our own image. So the image right here is the website latest. And you can see the name, the ID, and it's mapping port 8080 from the host to 80 inside of the container. And the crucial thing here is that we are not mounting any volume. So this image contains everything that our application needs in order to run. Now let's go ahead and test this in our web browser. And then this was the previous one. So now if I refresh, you can see that this still works. So if I open up Safari and then localhost and then 8080, there we go. You can see that our website is working beautifully. And there you go. You've successfully managed to create a Docker file and then built an image from it and ran a container. If you have any questions, go ahead and drop me a message. Otherwise, let's go ahead and learn a bit more about Docker files. All right, let's go ahead and switch contexts and build an API using Node.js. So we're going to pretty much just switch from this awesome website to building an API using Node.js. So go ahead and install Node.js in your machine. So for Windows and Mac users, the installation process is the exact same thing and very straightforward. So go ahead to nodejs.org and download either the recommended version or the one that contains the latest features. So once you have Node.js installed, we're going to be using this awesome framework called Express. So Express allows us to build APIs and web applications. So once you have Node.js installed, go ahead and navigate to expressjs.com. Go ahead and click on Getting Started and then Installing. So to install is very straightforward. You need to create a folder, npm init, and then entry point. This will be the index.js, and then you simply install the Express framework. So let's go ahead and do that now. So let me go ahead and open up terminal. And what I'm going to do is come out of the website folder. So cd and then dot. And in my desktop, I'm going to create a folder. So make and then dir and then API. Or actually, let's name this as user and then service. So this user service will contain every single piece of code that deals with users. So let's go ahead and pretty much just make this lowercase u, and then this also, let's go ahead and say dash and then service, and then enter. Or actually, let's also say API. So user service API, and then enter. Let's go ahead and navigate to user service API. Now let me show you the actual version of Node that I have. So node dash dash and then version. And for you, it might be a bit different, but this will also work for you, regardless of whatever version you are using. So now let's go ahead and say npm and then init. And go ahead and pretty much just press enter a couple of times. And then simply say yes, it's okay. Now inside we have this package.json. Now let's go ahead and install the Express framework. So npm install dash dash save and then Express. Just give it a second. And there we go. You can see that was very fast. Now go back to the website. And right here, so on the actual header, click on Getting Started and then Hello World. So right here, you can see that they have an example of how to run a very simple server with one route that simply returns Hello World. So go ahead and copy all of that. And what I'm going to do is open up VS Code. So let me go ahead and simply open. And then in my desktop, user service API, and then open. There we go. Now inside, let's go ahead and create an index.js and then paste that code. So just simply paste everything and save it. Now the way that you start this is if I go back to the terminal, and you can see that we have this index.js. Now go ahead and simply type node and then index.js. And you can see that we have a message saying example app listening on port 3000. Now let's go ahead and open up port 3000 on our web browser. So localhost port 3000, enter, and you can see that we have Hello World. Now let me go ahead and simply change this a bit. So right here, instead of returning Hello World, let's go ahead and simply say res dot and then JSON, and let's return a user. So name, Bob, and then email, bob@gmail.com. So this will be enough. Save this, go back, open up terminal again. So we need to stop this, Control C, and then let me clear the screen, and then say node index.js, and there we go. App is listening on port 3000. Let's go ahead and open up Chrome again, refresh, and you can see that now we have a JSON object back. And in fact, this should be so let's go ahead and actually return an array. So an array here, and then close that one there as well. So this is a single object, but we want an array. So let me go ahead and cancel again. There we go. If I open up Chrome, refresh, and now you can see that we have an array of users. And there we go. So you successfully managed to create a very simple API with Express. Next, let's go ahead and Dockerize this API using a Dockerfile. So currently we have an Express app that simply has one endpoint, and it simply returns a list of users. So let's go ahead and actually take all of this and create a Docker file that will allow us to produce a Docker image. So let's go ahead and create a Docker file. So Docker and then file. So now we have to choose the base image. So let's go ahead and simply say from, and if you have guessed it, so if I open up Docker and then hub, and I can go ahead and search for node, and you can see that we have one verified content, and this is the Docker official image. So this means good news, as we can use node for our base image. So let's go ahead and simply say from and then node, and then let's go ahead and pick the latest tag. So I'm going to discuss tags later on, but for now, let's go ahead and use the latest tag. Next, let's go ahead and use work and then dir, so work directory. So what I want to do is actually set the working directory inside of the container. So what I'm going to do is create a folder called app. So basically this means that if you have a folder inside of the container called app, use it, otherwise create a brand new one. And then any commands that follow this line right here will be executed inside of this app folder inside of the container. Next, let's go ahead and pretty much just say add, and we want to add everything. So we want to add everything inside of this directory to the app directory. Next, let's go ahead and use the run command. So run, and right here, the run command allows us to pass few arguments. So the arguments that I want to pass is npm and then install. So basically we want to install all the dependencies from our package.json. So this allows us to do that. And finally, once we have all the dependencies installed, we can simply go ahead and pretty much just type the same command that we did here. So right here, if I cancel this, Control C, node, and then index.js. So let's go ahead and simply say cmd for command, and the command is node and then index.js. And there you go. This is pretty much everything we need for this Docker file. Now go ahead and open up terminal or command line, and let me go ahead and pretty much just press Control C, clear the screen. Let's go ahead and simply say Docker and then build, and make sure that you are inside of the user service API folder. And let's go ahead and simply name this as user-service-API column and then latest. And I forgot to add -- tag or dash T, so dash T for tag, and then where the Dockerfile is inside of this directory, so dot, and then press enter. And you can see that there are 5 steps. So the first one is from node. You can see that it's pulling node. So these are layers, which I want to discuss later on. But for now, it's just downloading everything that it needs for step 1 out of 5. So just give it a second. And you can see that this is the one that's taking the longest. So this has quite a big size right here. So 215 megabytes. So I think this was me actually dragging this. So just give it a second. And you can see that this ID right here is the same as that one. So just bear with me. Now it's extracting. There we go. So you can see that now it's doing the, oh, actually this is very fast, but basically you can see that it's finished. But let me show you exactly what it's doing. So the step 2 was creating the app directory, and then step 3 out of 5 was adding everything from our local machine to the container, and then step 4 was running npm install to download and install all the dependencies. And then step 5 is the command. So when this container starts, what command shall be executed? Node and then index.js. And you can see that this is the image ID and this was the actual tag. So user service, API, and then latest. And this was actually me copying and pasting, so ignore this. And there we go. Now we have an image for the user service API written with Node and Express.js. Let's go ahead and run a container from the image that we've just built. And what I'm going to do is make sure that the API is not up and running. So let me go to localhost port 3000. You can see that it's not up and running. Now, let me go ahead and check the list of images that I have. Docker, image, and then ls. And you can see that we have 2 extra images. So this one, node, and the one that we've just built. So user service API. So you can see the tag as well. So the tag is latest and the image ID, created at, and also the size. So now let's go ahead and pretty much run a container from this image right here. So to do that, let's go ahead and simply say docker and then run -- name. Let's name it as user and then -API, and the actual and then -d for detached, dash and then p for mapping the host port to the container port. So let's map the port 3000 and remember correctly. So if I open up Chrome, it was running on port 3000. So this is the port that Express.js listens on by default. So let's go ahead and pretty much just map to that. So the host 3000 will map to container port 3000. And then let's go ahead and pass the actual image. So user -service -API and then column, and then the tag is latest. And I can see that I've got a mistake. So this should be docker and then run, not rum. And then press enter. And there we go. Now go ahead and simply say docker ps with format or without, it doesn't matter. So I'm going to format the ps output, enter. You can see that we have 2 containers. So we have the website. So this is running on port 8080. And this is the API, which is running on port 3000. So let's go ahead and test it out. So let me open up Chrome. And then right here, you can see that this was running from our machine before. and now it's been containerized with Docker. So if I refresh, you can see that now it's working. And also our website is listening on port 8080 and should work. So you can see that it's working. And there you go. You've managed to containerize an Express application with Docker. If you have any questions on what we did here, drop me a message. Otherwise, let's move on. In this section, let's go ahead and learn some of the best practices when it comes to writing Docker files. So in this video, I want to cover the .dockerignore file. So far, you've seen that we wrote this Docker file right here that says from node latest. And then we set the working directory right here. And then any command that follows will be executed inside of this folder called /app. So you can see that right here, we simply add all the contents within the host. So all of these files to this folder right here called app inside of the container. And then we simply run npm install. So usually when you write applications, there are certain files that you should ignore. For example, if I was to commit this API to a GitHub repository, I wouldn't necessarily commit this folder right here called node_modules, because this folder right here is created when we run npm install. So in fact, let me go ahead and delete it. So let me go ahead and simply delete. And then you can see that if I try to run this application, so let me go ahead and simply say node and then index.js, you can see that cannot find module express. So what we do is simply say npm and then install or npm I. There we go. You can see that the packages were added and about 50 of them. Now if I go ahead and say node and then index.js, you can see that this time this works. So what we need to do is right here. So because we don't need to include this folder to our build step inside of this Docker file, right? Because this command right here, so run npm install, does it for us. We simply have to exclude this file right here. And so that you understand, by the time you run this command right here, it will include everything in this folder, including node modules. Then you will also run npm install, and that will create the node modules again. So we don't need that. So what we need to do is create a new file, and this file will be called dot and then all lowercase docker and then ignore, and then press enter. Now what we need to ignore is node_modules. And in this file, you should ignore folders or files that your Docker image does not need. So we also don't need the Docker and then file. So we don't need this Docker file, so this one right here, to be added to our image, right? So it adds no value because we don't need this Docker file in order for our application to run. Finally, because I'm going to create a GitHub repository from this example right here, let me go ahead and simply add a dot and then git. So this is the git folder, and I really don't need to include that inside of my image. And for example, if you want to exclude files ending in certain extensions, you simply say, for example, file, or actually you'd say star, so any file ending in, for example, dot and then gulp, for example, .js, something like that. If you want folders, you'd say folder and then / and then any folder under that, right? And this is pretty much it. So I'm going to ignore node modules, Dockerfile, and .git. So now if I go ahead and save this, and let's go ahead and pretty much cancel out of this. Let's go ahead and build the image. So Docker build. And in fact, let me check the image name. So Docker image ls. So the image was user service API. So Docker build -t, paste that. Let's also go ahead and simply say latest, and then dot, enter. And you can see that it's running. It added 50 packages. So this was the npm install, and there we go. And this is how you use the .dockerignore file. If you have any questions, go ahead and drop me a message. Otherwise, let's move on. In this video, let's go ahead and learn about layers and caching when building images from our Dockerfile. So pretty much every one of these steps, so step 1 to 5, they do create layers. And a layer is used in caching. So how is this important to us? So what I'm going to do is pretty much open up terminal. And right here, let's go ahead and install a few dependencies. npm install -S. Let's go ahead and install React, Webpack, and then let's also go ahead and install gulp and grunt. So basically, I'm just installing random packages that you don't necessarily need. So this is only for demonstration purposes. So go ahead and press enter. And you can see that this will take a while. So it will download React, Webpack, gulp, and grunt. So just bear with me. And there we go. You can see that it added a few packages, and this took a while. So now let's go ahead and open up our code. And what I want to do here is open up index.js. And if I make this smaller so you can see everything. So right here, let's simply go ahead and add another user. So let's call this Alice, and then Alice at, and then hotmail.com. Now let's go ahead and build an image from this. So go ahead and pretty much just press up a couple of times. And what I'm going to do is this one. So I need this command, docker build -t user service API, and then latest, and then dot. So you've learned about this. So now go ahead and press enter. And you can see that these are the steps, and each step, so you can see that right here. So this step is using cache. So you can see that it's using the cache, right? So just give it a second, and you can see that now this will take a lot longer because we are installing a bunch of dependencies, and you can see that it's finished, right? So the point really here is that you can see that step 1 is pulling the node image, so latest, and then work directory is using the cache, but really there is not much going on inside of this work directory. So this is simply saying create this folder if it doesn't exist, otherwise use it. And then we add the source code right here, and then we run npm install. So if I run the application, so let's go ahead and run. So run, just like that. Press enter, and there is a container already. So let me go ahead and say docker rm, and then -f user -api. There we go, that's gone. So if I run this again, and then open up my web browser, and if I refresh, you can see that we have 2 users right here. So we have Bob and Alice. Now let's go ahead and add a 3rd user. So right here, let's go ahead and add Jake, and then add, and then yahoo.com. Save this. Now let's go ahead and build an image again with our changes. So go ahead and pretty much just say docker build, basically the same command. Press enter, and you can see that it's running the same thing. So basically from node right here using the cache, adding our source code right here, and then running npm install. And you can see that took a while. So the thing here is that we can do way better than this. So we can take advantage of caching, because the only thing that we have changed was the source code. So because the source code has changed, right? So let me go back to the Dockerfile that we built. So because this step has changed, Docker has to recompute every single step that comes after this. So the way to improve this and to make sure that we do not run npm install and download and install dependencies all over again, we can simply take advantage of caching. So let's go ahead and think how we might improve this Dockerfile. So we know that what we need from this Dockerfile is two things. We need the package.json and package-log.json. So what I'm going to do is I'm going to set the working directory. And now here I'm going to say add, and then I'm going to say package, and then star.json. So basically, I actually missed the dot right here. So we want to add package.json to the working directory, which is app. So basically now we are adding the package.json, right? And what we're going to do is pretty much run npm install. And then after that's complete, we're going to add the source code. So we're going to add everything from the current directory right here to our working directory inside of the container, which is app. And then we're going to run node and then index.js. So this will improve things dramatically, because we don't often change what's inside of the package.json. Surely at the beginning of development, but once the software is mature enough, we don't necessarily add too many dependencies. So we can simply use caching, right? And then Docker will know whether the contents of package.json or package-log.json changed, and then recompute everything all over again. If not, it will just skip this step, use whatever it's been cached, and then pretty much just add the source code and then run node and then index.js. And this will be way much faster. So let's go ahead and give that a go. So let's go ahead and build. So let's go ahead and build this for the first time. So docker build -t user API and then column latest. And it says when using add with more than one source file, the destination must be a directory. So what I need to do is simply say / and then dot. And this should work. And I think I got a mistake. So this should be dot and then / like that. And let's go ahead and give that one more try. So docker build, and there we go. So it's working now. So you can see that right here. So it's pulling the node image. It's using the cache for the working directory. And it's added the package and package.json and then a package-log.json, and then right here it ran an npm install, right? And this is done. So right here, so you can see that step 5 was simply adding the source code, and then step 6 is the actual command. So node index.js. So now let's go ahead and pretty much just add a 4th user. So right here. So let's go ahead and add Maria, and Maria at yahoo dot and then com.uk, something like that. And then let's go ahead and go back, and now let's watch this closely. So now if I build an image from this Dockerfile, guess what? So you can see that this was so much faster. And why? It was simply because of this step right here. So right here, you can see that it's using cache, which it wasn't before. And the same for the package and then start.json. So nothing has changed there. And in fact, you can see, so let me start from the top. So right here, using cache. So this is for the working directory. The same for adding package.json. The same for npm install right here. So this is awesome. And then the only thing that changed was the source code, which was inside of this step. And this is much better because now we are using caching, and you can see that building images this way was much faster. So bear in mind when you create your Docker files to think exactly what will change and what will not, and try and make use of caching whenever it is possible. Now let's go ahead and test this by bringing up a container from this new image. So let me go ahead and check the images that I have. So Docker PS, let me clear that. And we have this user API. So let's go ahead and stop it. So Docker rm-f. So we want to stop and remove. And let's go ahead and simply say user API. Now let's go ahead and simply start user-API like that. And this will be using the new image. So press enter. There we go. Now if I open up my web browser and then right here, let's go ahead and refresh. You can see that it's working. We have Maria right here. So Maria was the last user that we added. And there we go. Now we have an understanding of Docker, caching, and layers. Go ahead and drop me a message if you have any questions. Otherwise, join me on the next one. Alright, in this video, let's go ahead and learn how we're going to improve our image sizes with Docker. So let's go ahead and simply check the images that we have. So Docker and then image ls. And right here, you can see that we have a couple of images. So we have our custom image that we've been working with. So user service API latest. And we also have the website image, node, and then NGINX. So if you look carefully, so we have this size column right here, and you can see that the size is, to be honest, quite large. So this is almost 1 gigabyte, right? But then if you look into this website, the NGINX one, right? This is based off NGINX. The size is 135 megabytes. Now, when building images and pulling images, you will see that the time that it takes to download these images is quite large. So one way to reduce the image size is to use the Linux Alpine distribution. So what I want to do is actually show you exactly what it is. So go ahead to alpinelinux.org, and right here you can read about it. But basically, this is an independent, non-commercial, general purpose Linux distribution designed for power users who appreciate security, simplicity, and efficiency. And right here you can see that the key points are it's small, and you can see that a container requires no more than 8 megabytes, and a minimal installation to disk requires 130. So you can see that, you know, the sizes here are really tiny, really minimal. It's simple and it's secure. So go ahead and read more about the Alpine Linux distribution. But what I want to show you exactly is how we can reduce the file size of our images, because this is very important when you start building a bunch of Docker images. So let's say that you have 100 Docker images, right? So one, you will fill up your Docker registry very quickly, so you run out of space. And we're going to touch about Docker registries later. And the other one is actually, you know, speed. And also in the actual images that we have, sometimes we don't need everything in it. So that's why we use the Alpine image. So let's go ahead and learn exactly how we are going to reduce the file size of our Docker images. All right, so pretty much every single Docker image out there has an Alpine version, or actually an Alpine tag. So right here, you can see that we have a node. So this isn't ours. And we also have NGINX, and they are using the latest tag. So let me go ahead and show you the actual image. So this one is for node. And right here, you can see that they have supported tags. So by default, when we don't use a tag, we pretty much just get the latest tag, or as we've been using tags throughout this video, we have simply been using the latest tag. So right here, you can see that they have a bunch of tags, and the one that we've been using is node. But you can see that, for example, you have 8.16.0 and then Jesse. You've got Buster, but more importantly, the ones that we care, right, because we want to reduce the file size, is the Alpine version. So you can see that 8.16.0 and then Alpine, and then you have 8-Alpine. So let's go ahead and pretty much just pull an Alpine image and then investigate the actual size. So let's go ahead and simply say Docker and then pull. And what we're going to do is we're going to pull node and then say column and then LTS for latest and then dash and then Alpine. Now let's go ahead and press enter. And you can see that this is pulling the image from library-node. And you can see that this is 21 megabytes and pretty much it's done. So you can see that it was very, very quick. So let me actually go ahead and pretty much just clear the screen, Docker image ls. And now take a look at this. You can see that now our node image, so latest Alpine, it's only 75 megs. So we went down from almost a gig to 75 megabytes. So this is insane. And you saw that to pull this image was like very, very fast. And remember previously when we pulled this image right here, right? So when we pull this image, this took ages. So, you know, I had to wait because my internet connection was slow, but right here, you saw that pulling this image was very, very fast. Let's go ahead and do the same for NGINX. So go ahead and simply say Docker pull, and let's go ahead and search for the latest NGINX tag. So let me go ahead and pretty much just navigate and search for NGINX. And let's look at the tags that they have. So you can see that they have also Alpine, right? And they have latest. So let's go ahead and pretty much just say that we want the latest, actually NGINX here first. So this is the name, so repository name. So NGINX column latest dash Alpine. Press enter. And you can see that it's actually not called NGINX dash NGINX column latest Alpine. So I think that, okay, I got mixed up here. So basically, if we want Alpine, we simply say Alpine and then it will get the version, right? So basically these are the versions. And if you don't include the version, right? So if we simply say Alpine, it will get the latest one. So let's go ahead and pretty much just run the same command again. And instead of latest, we simply say Alpine. Enter. And there we go. So now you can see that it's pulling the image. And this was like very fast. So let's go ahead and clear the screen. And then Docker image ls. Enter. And now let's look at this. So basically we now have two NGINX images. So this one was the latest, right? And this one is the Alpine version. And you can see that the size, this one is pretty much tiny in comparison with this one. This one is 126 megabytes, and this one is only 21 megabytes. And this is awesome. There we go. You now know how to reduce the image file size by using the Alpine Linux distributions when pulling Docker images. Next, let's go ahead and change our own images. So this one, user service API, to use an Alpine version, and the same for our website. Let's go ahead and change our custom images to use the Alpine version, and you will see that the size will become much smaller. So let's go ahead and change for the user service API, and the same for our website. So let's go ahead and open up VS Code or your favorite IDE, and I'm inside of our API, and what I'm going to do here is pretty much change this to Alpine. And I think that right here we use the LTS Alpine. So let's actually double check what's the difference between Alpine and LTS Alpine. So let me actually go ahead and go to Docker, or actually Node. So Node, and right here, so we have the Alpine version and LTS and then dash Alpine. So basically, I think I've used this one previously, but we also have the Alpine right here. So let's actually use the Alpine. So what I'm going to do is pretty much just say Node and then Alpine here, save that. And let's also go ahead and say Docker RM, or actually image RM, and then Node, and then get the actual ID. So let's remove this image. There we go, that's gone. And let's do a Docker pull and then Node column al and then pine. So I think this is much better. There we go, and you can see that this will be super fast. There we go, that's done. So if I do a Docker ls image, or actually image ls, you can see that we have Node Alpine right here, and it's only 79 megabytes. So that's fine. Now let's go ahead and change the actual website. So let's go ahead and open up website. So file and then open and desktop and then website. And right here, this will be NGINX and then Alpine. Save this. Now let's go ahead and build these two images. So Docker build, and we are going to build the user service API, right? So make sure that you are inside of the folder, and then name this as latest, and then simply say dot, press enter. And I always forget the tag, so let's go ahead and simply add a tag, build, and then -t for tag. There we go. So you can see that now it's pulling from Node Alpine, and this is taking a while because of caching. So remember that this layer right here, so this layer right here has changed, right? Therefore, we need to recalculate everything that comes after it, even the work directory. Remember, before it was getting from the cache, the same for package.json and npm install. So we've changed the image, so now it's recalculating everything. So if I actually go ahead and I want to show you this. So if I build the same image again, so this was like super fast because it's using the cache right here. You can see that it's using the cache, using cache, 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 and cache, because nothing has changed. Now let's go ahead and cd back and then go to website, and let's go ahead and pretty much just build website. So Docker build -t and then website column latest. and then dot. Enter. And there we go. You can see that this took like, probably half a second or so. And this is because there isn't much that we have to do in this build, because we simply are pulling Alpine and then adding the source code, and that's it. So now let's go ahead and say Docker and then image and then ls. So now you can see that we have the website right here, right? So the website now is only 30 megabytes and before was 134. So I'm going to explain this later on, but you can see that now we have none and none. So the repository went from none and the tag also went from none. And that's because we are overriding the tag. So it's pretty much reusing the same tag. And because you cannot have images with the same repository and tag, with the same repository name and tag, it simply removes and then uses for the new build. So that's what we did. That's what it did here. So website latest is only 30 megabytes. So you can see that it went from 135 to 30. So this is a big improvement. Now let's look at our user service API. So remember, this was based off Node. So this big one right here, almost a gig. So now it's actually 117 megabytes. And before, you can see that right here. So this one, it was 946 megabyte, which is almost a gig. So there you go. You can see that we've managed to improve the file size of our custom images. If you have any questions on reducing the file size, go ahead and drop me a message. Otherwise, let's move on. In this section, let's go ahead and learn the importance of tags, versioning, and tagging our own images. So basically, tags versioning allows you to control image version, i.e. you have full control of what image you pull and what image your application depends on. And the benefit of that is that you now avoid breaking changes. So let's say that you code against Node 8 today, and then tomorrow Node, let's say 12 comes out. If you are using the latest, then you pretty much, switch to Node 12 without testing whether your application works on Node 12. I'm going to give you an example in a second about this. And also it's safe, right? So when you build images, you have to make sure that they are safe. You have to make sure that you fix any security patches. And with tags and versionings, you can achieve that. So let me give you an example of tags and version. So let's say that today you run Docker pull node Alpine and the current version of Node is 8. Just imagine, right? The current version of Node today is 8. And then tomorrow you run the exact same Docker pull command, so Docker pull node Alpine, and then the node version is 12. Now, how do you make sure that your application that you have bundled against Node 8 works against Node 12? You don't know, right? So this could have an impact on your application and you could have lots of breaking changes. So the same if you are using Node latest, right? So the Alpine version, it's pretty much the smallest Linux distribution, but it would be the same thing. So here you are pulling the Node latest and it's the exact same example. Now, the better way of doing this is that you have full control. So what you do is pretty much say, I want to pull Node, and then you say 8-Alpine. So right here, you are literally specifying the version that you want. And then tomorrow, if Node 12 comes out, you can decide whether to switch to Node 12 or not, right? But right here, you have full control of the version and tags that you are using. Let's go ahead and change our current images, both NGINX and node to point to a specific version and tag. Go ahead and open up the Dockerfile for our website, and let's go ahead and change this very first line, so from NGINX Alpine to use a version, right? So right here we are simply depending on the latest version of NGINX, right? So the smallest distribution right here, but we want to stick to a version and have full control. Now, where you actually find the versions is if you go ahead and open up Docker Hub. So let's go ahead and search for NGINX and NGINX. So this is a verified one. And right here, you can see that supported tags and respective Dockerfile links. So right here, you can see all the tags with versions. So right here, you can see that, so we are using the Alpine version right here, Alpine. But what we want to do really is just stick to a version, right? So you can see that we have 1.17.2, or actually 1.17.2-Alpine. So you could go ahead and also try all of the other versions, but as we've discussed in this course, the Alpine is the preferred choice when building Docker images. So let's go ahead and pretty much just stick to this version right here, 1.17.2-Alpine. So let me go ahead and simply grab that and then simply say 1.17.2-Alpine. So this is my tag. Now I have full control. Let's go ahead and also do the same for our API. So go ahead and open the user service API. And there you go. So right here, you also see that we have from, node, and then Alpine. So let's change this to use a specific version and tag. So go back to Docker Hub, and then let me go back. And right here, you can see that you have a bunch of tags, right? So let me just quickly show you that if you go to nodejs.org right here, you can see that they have two versions right here. So they have the 10.16.1. So this is the latest recommended for most users. And then you have the latest features. So this is 12.7.0. So go ahead and pick the one that you feel most comfortable with. So I'm going to go with 10. So Node 10, the recommended for most users. So let me go back to Docker Hub, and we should have a version 10. And by the way, that version might be different for you depending when you watch this video. So let me actually go ahead and search for the Alpine version, and I want 10. So you can see that right here. We have 10.16.1, right? So this is pretty much the same one. So let's go ahead and take this. So 10.16.1. So let me go back to VS Code, and this will be 10.16.1-Alpine. And to be honest, this is all. So you can see that now we have full control of these versions. The next thing that we have to do is simply build these images and see the next thing that we have to do is to build these images and make sure that everything is working fine. So next, let's go ahead and build and run the containers using these tags with a specific version. All right, let's go ahead and build images for these new tags and then run the containers. So I'm inside of the website folder. So let's go ahead and simply say Docker and then build -t website and then column latest. And we also will learn how to tag our custom images. So for now, simply say latest and then dot. Press enter. And now you can see that it's pulling from, and you can see the tag and actually the version and tag that we have specified. So NGINX 1.17.2. Let's go ahead and do the same for the API. So cd and then back a folder and then user service API. Let's go ahead and tag the same thing. So I think this was user-service-API and then press enter. There we go. Now you can see that this changes, right? And because I've changed the version, it's not using the cache. It has to recompute everything again. So just give it a second. It's running npm install. And there you go. Now, if I go ahead and clear the screen and say Docker and then image ls, you should see that we have user service API and website. Now, don't worry about seeing lots of none here, and I'm going to explain why this is happening later. Now, let's go ahead and run both the website and the user service API. So Docker and then run, and let's go ahead and run that. Expose import 3000, and it seems that we already have a container with that name. So Docker and then rm-f and then grab the name, and I think it should be just that. So that's incorrect. So Docker and then ps or Docker ps-a. And you can see that we have to remove user API. So let's actually run the same command. So it should be that. So user and then dash API. There we go. And let's do the same for the website. So website. Now let's go ahead and create a container or run a container for our API first. And then let's run our website container. So website, and if I search, we should have website like that, and then enter. There we go. Now let me go ahead and open up Chrome, and if I go to localhost 8080, so this is the website, you can see that this is now working with a specific version and tag. And let's also do the same for our API. So if I refresh, you can see that this is working. So now we have full control of tags and version for our Docker images. If you have any questions on this, go ahead and drop me a message. Otherwise, let's go ahead and learn how to properly tag our own images. So before we learn how to tag our own images, go ahead and type Docker image and then ls. You can see that we have 4 images right here that have no repository nor tag. So this is because every time we made a change and we use the same tag, so latest, so this tag right here, so website-latest, we have to override the existing image. So what I'm going to do is actually build this, and I want you to see that this will remain with 4 of these because it will use the cache. So if I do a docker ps, or actually image ls, you can see that we still have 4. But now let's go ahead to Docker Hub, and let me go ahead and search for NGINX, and let's go ahead and pretty much just use one Alpine, so this version right here. So go back to VS Code and then open website, and then right here simply say one Alpine, save this, and then let's go back to terminal and then run it. So let's actually tag this again. So let's now build an image for our website and use the same tag. So website column latest, and you can see that now it's pulling the one version, one-alpine, and successfully built a tag. So now remember right here, so this is the one that was using this version. So let me actually go back and then and comment this and save because I want this version. So this version right here, right, is for this one, but we have named it as latest. Now, if I go ahead and clear the screen, and let me actually delete that and simply clear the screen again and say Docker image and then ls, now we should see 5 images without a repository and tag. So this will override. So there we go. You can see that now we have 4 and 5, right? So now that you know that whenever you make a change to your image and then use the same tag, you will override the existing one, remove the repository and tag. Next, let's go ahead and learn how to properly tag our images. All right, so currently we have this website right here, right? So if I show you, so we have this website, Grayscale, and pretty much we haven't done anything with this website. We haven't modified it. We haven't done anything. So usually you add features incrementally, and then you have an image for a complete feature. So let's say that we want to update this website right here. Instead of Grayscale, we want to say Amigos Code or your own company. So the way tagging works is, what I'm going to do first is collapse that, and I'm going to build. So I'm going to build a new tag. So this time I'm going to call it website, or actually Amigos Code, and feel free to use your own name if you want. So Amigos Code website, and this is the latest. So this is the latest one. So I'm going to build this, and you can see that now if I do a Docker image ls, you can see that I have now Amigos Code website, and this is the latest. Now, the way I'm going to tag this is based off latest and then use a specific version. So let's go ahead and simply use this Docker and then tag, and we want to tag from Amigos Code dash web site column latest, and from that we want to build a new tag. So let's go ahead and simply say Amigos Code dash web site and then column and then 1. So if I press enter, you can see that this works. And now if I do a Docker and then image ls, you can see that I have latest, right? So this is the latest version, but we also have the versioned number. So Amigos Code website, and then this is version 1. Now both of these images, they do have the same content as our running website. So this one. So now what I'm going to do is open up VS Code and open up the website folder. Let me make this smaller so you can see exactly everything. Open up now index.html, scroll to the bottom, and you should see the H1 right here, Grayscale, and change this to Amigos Code or your own name. And you can also go ahead and change this description, the same with that one. But for now, I'm going to simply save this as it is. So now I'm going to save this and then open up terminal. And now I have a new change. And what I'm going to do is tag again. So I'm going to tag this as latest. So this now is the latest image that contains our changes. So I'm going to press enter. There we go. And now watch this. I'm going to tag from latest, and then I'm going to create a new tag right here. This is a tag name. So from, so tag, this is the from, and then this is destination. Now here, I'm going to say this now is version 2. Press enter. And if I clear the screen, Docker image ls, and there we go. So now you can see that we have Amigos Code website 1, Amigos Code website 2, and we also have latest. So this will always point to the latest tag number. So now let's go ahead and spin up two containers, one using the first version of the website and the other one using the second version of the website. And also, why not, let's spin up the one using latest. So let's go ahead and do that in the next video. All right, let's go ahead and run a container for Amigos Code website tag and then 1, Amigos Code website tag and then 2, right? And let's also run one for Amigos Code website and then latest. So I want you to see exactly how this works. Now let me go ahead and clear the screen. Docker PS. So let's go ahead and kill the website. So this website right here, because we're going to reuse this port right here, 8080. So say docker and then rm -f and then website. There we go. And let's also delete the user API. So why not? There we go. So now if I do a docker ps, you can see that no container is running. Now let's go ahead and run the website and then version 1. So let me actually copy from here. So right here, let's go ahead and say Amigos Code website. And then latest. And then this will be Amigos Code website, and then the tag is latest. So this will be 8080. Now press enter, and there we go. Let's now change this to 2. So this will be the version 2, and let's go ahead and change the name because they can't be the same, and the same with ports. So this will be 8081. Enter. And now let's go ahead and run the version 1, and this will be on 8082, and then this will be 1. So Amigos Code and then 1. Well, actually I could have said Amigos Code website 1 for the name, but it's fine. You get the point. Now if I press enter, you can see that they are both running. So now let's actually do some testing. So remember, right? So remember, the latest one was based off the version 2, right? So if I refresh this page, you can see that now I do get Amigos Code. Now let's go ahead and change this to 8081, and we should also get Amigos Code because this is the version 2, and version 2 contains the latest changes. And this one running on port 80 is the tag Amigos Code website and then latest, and it's based off version 2. So that's why they are the same. Now let's go ahead and run localhost and then 8082. So 8082 is running the first version of our website. Now the content should be different because we are running a older version. If I press enter, you can see that now this says gray scale. And this is the power of you having control of whatever version that you are running when you deploy your website. Because let's say that you have deployed version 2. Now let's say that you had a spelling mistake and your CSS had a bug, right? So, or even like a button, right? So this button wasn't working for some reason. Now, instead of you taking time and fixing, why the button wasn't working and all the spelling mistakes, what you can simply do is go back to a previous version. And then while you fix it, you are guaranteed that your website was working as it was before, right? So you could go back to this version right here without no problems, and then fix your bugs, and then create a brand new version. So then you create version 3 and then deploy that. So this is how you tag your own images using Docker. So if you have any questions on tags, go ahead and drop me a message. Otherwise, let's move on and learn how we're going to push our images to a container registry. In this section, let's go ahead and talk about Docker registries. Docker registry is simply a server-side application that lets you store and distribute Docker images. So far, we've been building images in our host machine, but eventually we want to take our images and store it in a server-side application. So that's what Docker registry is. We also can use Docker registries for our CD/CI pipelines, i.e. continuous delivery, continuous integration pipelines. So usually this is when you pretty much just spin up a bunch of images to achieve a certain task according to your pipeline. And also it's used for running our applications. So you can take your container from your host, upload it to a Docker registry, and then use it to run instances of your application, right? So as we've been doing, running containers. And you could use, for example, Google Cloud with Kubernetes, or some of the services provided by AWS, such as Elastic Beanstalk. So the idea is that you have images in your host. So this is our current scenario as we've been doing throughout this course. And you also have a Docker registry. So a Docker registry, as I mentioned, is simply a computer server that holds all of our images. And to ship images to any Docker registry is very simple. All you have to do is use a command called push, and that takes the images and puts it inside of the Docker registry. And we're going to learn about this in a second. So when it comes to Docker registry, there are two types. You have private and public registries. So it really comes down to your needs. So you might have images that you don't mind other people see it and use it, or you might have personal projects, or you are working on an application that you don't necessarily want people to have access to your image. So that's when you use a private registry. In terms of Docker registry providers, there are quite a lot of providers, but let me just mention the most popular ones. So you have Docker Hub. So this is where we've been pulling public images such as NGINX and Node. You also have Key.io and also Amazon EC2 Container Registry. Let's go ahead and push our images to Docker Hub. Let's go ahead and take our images that are running the website as well as the API and store them in a container registry. So for this course, we're going to be using Docker Hub. So navigate to hub.docker and make sure that you are signed in. So Docker Hub gives us the ability to store both private and public images. So in fact, when you go to Docker Hub, so let me go ahead to Docker Hub. And right here, let's go ahead and simply search for an image. So right here, you can see that they have a bunch of images, but all of these images, they are public. So if I pretty much click on Mongo, you can see that I can pretty much just say Docker pool Mongo. So let's go ahead and also store our own images. So go ahead and pretty much, as I said, navigate to hub.docker and make sure you sign in. And then right here, you can see that they have this section here, this menu item, repositories. So go ahead and click on it. And there you go. So you can see that I have no repositories found. So let's go ahead and create one. And also, so just to bear in mind that you can see that they give you one private repo. So that's really, really awesome. So if you have, for example, a website or a full stack web application, you can take advantage of this private repo and then have an image that you are the only one that has full access and control to that image. So let's go ahead and create a repository, and you can give a description right here. You can give a description, but let's go ahead and create one first for the website. So website, and then give a description. So let's say main web site, and you can elaborate on this. So what I'm going to do is actually select public. So I don't need this to be private because I want to share with you. And then go ahead and simply say create. And there we go. So now we have a repository. So you can see that right here, the way that you push images, it's very simple. So you simply say docker push, and then this is your account. This is the actual repository, so website, and then the actual tag name. Next, let's go ahead and learn how we're going to take an image from our host and push to our repository hosted by Docker Hub. Now that we have a repository with Docker Hub, let's go ahead and take an image from our host and push it to our repo. So you can see that right here, they have this command right here. So you can see to push a new tag to this repo, simply say docker push, and then this is the username, and then this is the actual tagging. So what we need to do is first, let's go ahead and pretty much close this. So what we need to do is simply say docker image and then ls. So you can see that we have a few images right here. You can see that the repositories are Amigos Code website. You can see that you have Node, NGINX, a user service API. You might even have more or less than me. So what we're going to do here is simply take Amigos Code website latest, Amigos Code website 1, and also 2, and let's push all those 3 images. So what we need to do here is to tag a new images according to the following. So the first part is username, website, and then tag name. So let's go ahead and do that. So let's go ahead and simply say docker and then tag, and then Amigos Code dash website, and then column 1. And then we want to tag this to Amigos Code /website column 1. So this will be our new image right here. So let's go ahead and press enter. Let's do the same. So right here will be 2, and then this is 2. So remember tagging. So this is the source. So the source is this one. So Amigos Code dash website 2, which is this one. And then this is the actual new name. So Amigos Code /website column 2, which is pretty much the same as this one right here, right? So I'm following this standard. So let me go back and then press enter. And let's also take latest and latest here, right? So we have a latest right here. So this one. Now press enter. If I do a docker image ls, you can see that now we have Amigos Code /website, and then this is 1, Amigos Code /website 2, and Amigos Code /website, and then latest. Now the way that we push these images is first you have to log in. So you can see right here in this Docker logo, so you can see that I'm already signed in. So let me go ahead and actually log out. And you can log in 2 ways. So one, you can pretty much click on the logo, on the Docker logo again, and then sign in. And right here, you simply add your credentials, or using the terminal, simply type Docker and then log in. Go ahead and type your username. So my one is Amigos code, and then type your password. There we go. So now that I'm logged in, I can run this command right here. So docker push and then the actual tag. So let's go ahead and do that. So if I pretty much say docker push and then remember Amigos code /website :1, press enter. You can see that now it's preparing and it's pushing. There we go. Let's do the same for the version 2. And the images are not that big, to be honest, right? So remember, we are using Alpine, and this is the benefit of Alpine. There we go. And now let's also push latest. And finished. Now, if I go ahead and go back to Docker Hub, now if I refresh, you can see that I do have the 3 images right here. So I've got version 1 of my website, version 2, and the latest. So this is awesome. So you can see that now we have the images right inside of Docker Hub. And you know, it's secure. You can share it with other people and you can use it to run containers, so on and so forth. If you have issues getting this far, go ahead and drop me a message. Next, let me go ahead and show you how to search and pull your own images. All right, so we've pushed these 3 images right here for our awesome website. And inside of Docker Hub, what I want you to do is to click on Docker Hub. So basically click right here. And what I want you to do is simply search for your own username. So go ahead and actually search for mine for now. So simply say Amigos code. And then you should see this repository, right? So this is the website that we've just pushed in the previous video. So go ahead and click on it. And you can see that no overview is available. But if you're doing this for yourself, go ahead and add more information because it's always useful for someone that wants to use your images. So you can see that we have tags right here. So these are the 3 tags that we've pushed. And if I go back to overview, you can see that the command right here to pull the image is simply docker pull Amigos code and then /website. So let's go ahead and try that out. So let me go ahead and open up terminal. And what I'm going to do is simply say docker image ls. You can see that we have Amigos code website 1 here. So let me go ahead and simply say docker I for image. And then let's go ahead and simply delete the Amigos code website column 1 as well as 2 and then latest. There we go. Now if I do a docker image ls, you can see that it's gone, right? So we have this Amigos dash website, and this is from previous videos that we've done. Now what I'm going to do is simply say docker pull and go ahead and also try this. So simply say docker pull and then Amigos code /website and then press enter. And actually before you press enter, so because we're not specifying the actual version, whether it's 1 or 2, we will simply get the latest one. So press enter and you can see that it's using the default tag and done. Now if I do a docker image ls, you can see that we have Amigos code /website and then latest right at the top. Now let's go ahead and run a container from it. So run, and what we want to run is the actual website. So right here, let me simply add a /website, and I think that port has been used already. So let me go ahead and simply expose 9000, and then right here, this is / and then Amigos code, and then press enter. And we can't use / for the name, so let me actually remove that and simply say website. Enter. There we go. Now if I open up my web browser and then localhost and then 9000, and you can see that this is working, and it should also work for you. So there you go. This is how you push images to a container registry. We've used Docker Hub, but the process for pushing to Amazon EC2 container registry is the same, and also if you are using key.io, is the exact same process. And one last thing, remember that we had this API right here. So what I want you to do is to experiment this process on your own. So go ahead and push this that you have locally for this API to your own Docker registry. If you have any questions, go ahead and drop me a message and I'll be more than happy to assist. In the meantime, let's move on. Alright, in this video, let me go ahead and show you an important command that you might need to know in case you want to debug your Docker containers. So far, if I do a Docker PS and then format, you can see that I've got two containers running, and this is the actual API, and then this is the website version 2. Now, this Docker PS command simply gives us some information about this container, or actually these two running containers. But sometimes you want to investigate fully the configuration for a container. So the way you do it is simply by typing docker and then inspect. So you want to inspect, if I get this right, so you want to inspect, and then you can either pass the ID or the actual name. So ID or name. So let me go ahead and grab the ID for our API, paste that in. If I press enter, you can see that now this gives us a JSON format information. And right here we have a bunch of information about this running container. So if I scroll up, so right here you can see that you have the ID. This was the time that it was created. These are the arguments that we've passed, remember, so node and then index.js. You can see the state is running, paused. So basically you can see the full state for this running container. You can see the image, you can see some information about the log path, the name, the driver platform, it's Linux. You can also see the actual host config. So right here, this is more about the networking part. So you can see that right here, you have a port binding, right? So right now you have 3000 being mapped to 3000 on the host, right? So we've learned all about this. And then you have stuff such as restart policies, volume drivers. So if I scroll up, I just want to show you, you can see that we have the CPU period, devices, memory swaps. Right here, you can see that we have some read-only paths. And then if I scroll down, you can see some information about the graph driver, the mounts, the configuration right here. So we haven't got some environment. So this is the list of environment variables. So right here, so we have the path. This is the node version right here. So this is exposed by default, and also the yarn version right here. So you can see that, and some networking settings again. And there we go. So basically sometimes when you want to fully inspect your container, you pretty much run docker and then inspect and then the container ID or name. If you have any questions, go ahead and drop me a message. Otherwise, let's learn how to view logs for a container. Sometimes you want to view exactly what is going on with your container. So logs. So logs is a very important concept that you need to know, because sometimes you might want to monitor the traffic that goes to your container or any other logs that you have configured. So the way that logs work with Docker is very straightforward. So if I type Docker, well, actually, let me just press up a couple of times. So Docker PS, you can see that we have this user service API. Now, the way that you can see logs about this container is if I grab that name and then type Docker, and let me clear the screen for now. Simply type Docker and then logs, and then paste the actual container ID. If I press enter, you can see that this is the actual log that we saw way back when we configured Express.js. So you can see that this says example app listening on port 3000. So if I open up VS Code quickly, there we go. If I go to index.js, you can see that if I scroll down right here, so this is the actual log. So whenever you say console.log, you can see that we can capture that with Docker. So if I now go back to my terminal, and what I'm going to do is actually do a Docker PS again, and let's actually grab the logs for our NGINX website. So if I grab that and then say Docker logs, paste that in, you can see that now right here we have a bunch of other logs. So this is actually, if you look carefully, these are all the requests. You can see that there is a get request right here, another one here, another one here, and yeah, basically those. And if you scroll up, you can see a lot more, right? But what I'm going to do now is simply go back to Chrome, and let me go to my website, refresh, and then go back to terminal. So I want you to see this. So now if I do a Docker logs on the NGINX website, you can see that we are getting some requests. So this is really cool because now you can see exactly all the logs. And if you want to, for example, ship these logs to a service such as Umio or Elasticsearch, then you can do it, right? So what I'm going to do here is show you that you saw that I can type Docker logs every time to inspect the logs, but also there is this flag right here, dash and then F, and this means to follow. So if I press enter, you can see that now if I pretty much refresh this, so actually let me put it on the side like that, and this also. Now right here, if you watch the right hand side, if I pretty much just refresh, you can see that this also refreshes, and you can see that we get a get request right here. So if I press on get started, obviously nothing happens because this is a single page website, but you get the idea, right? So if I refresh again, you can see that it's following the logs. So this is awesome. And if you want to learn more about logs, so let me just resize this and then put in the middle. If I cancel out of this, so Control C, type Docker and then logs dash dash and then help. And this will give you all the commands that you can use with logs. So go ahead and experiment with logs, but this is very important when you want to debug your containers or everything that you log in your apps. If you have any questions, go ahead and drop me a message. Otherwise, I'll catch you in the next one. Sometimes you want to get into a container and see exactly what is going on inside of the container, right? So you want to go inside the box and see exactly what is happening. So remember when we did type Docker and then PS. And let's go ahead and grab the user service API. So let's go ahead and grab that, enter. Oh, actually not PS, but I want to inspect. So inspect. So right here, so remember that we saw that the actual box was Linux. So the platform was Linux right here. So sometimes you want to get into the box and pretty much just navigate your way around, or you might have installed some software on the box and pretty much you just want to debug even further why certain things aren't working. So the way that you jump into a container is simply by typing Docker. Or actually first, let me go ahead and describe all of these again so you can see. So the way that you jump into a box is simply by saying Docker and then exec and then -it. So let me actually go ahead and simply say --help so you can see the exact commands. So right here you can see that I stands for interactive, so keep the standard in open even if not attached, and then -t allocates a sudo TTI. So let's go ahead and simply type the exact same command, so docker exec -it, and then paste the actual container ID. And in fact I forgot, so let me format this again and then grab that container ID, and then let's say dash and then IT, pass the container ID, and then right here simply go ahead and say / and then bin / bash, and then press enter. And this failed, but it failed because we don't have bash here. And what I want to show you first is actually if we grab this ID again. So let's grab this ID, docker inspect. So this is how you use your debugging skills, and then search for cmd. And there we go. So right here you can see that the command that it was used to execute node was / bin sh -c and then node index.js. So let's go ahead and clear this. And now if I pretty much say docker exec it, now you can see that I can simply say sh, enter, and now I'm inside of the container. So if I type ls -al, this is pretty much the working directory that we have set within our Dockerfile for this API. So if I type pwd, you can see that I'm inside of /app. So if I do a cd and then .. go back, same command again, ls-al, enter, and now you can see that this is the actual Linux file structure.
Now that you have learned all about containers and Docker technology from Nelson's course, you can now start building complex applications with tens or even hundreds of containers that talk to each other or interact in some way. And of course, these containers would need to be deployed across multiple servers in a distributed way. So you can imagine the overhead and effort you would have if you had to manage these hundreds of containers manually with little automation. Every time the containers crash or the communication between them across the servers isn't working, you would have to manually interfere and fix these problems. So it would be great to have a tool that would automatically detect these problems and fix these issues itself to recover the application state. And that is the container orchestration tool. And Kubernetes is currently the most popular container orchestration tool out there. So in this course, we'll go through Kubernetes use cases. You will learn how Kubernetes works and how you can actually use it by showcasing some of the main Kubernetes components. And then, of course, we'll go through a practical demo where we're going to set up a simple application in Kubernetes cluster locally so that you can get your first hands-on experience with Kubernetes and get confident with the tool. So in this video, I'm going to explain what Kubernetes is. We're going to start off with the definition to see what official definition is and what it does. Then we're going to look at the problem solution case study of Kubernetes, basically why did Kubernetes even come around and what problems does it solve. We're going to look at the basic architecture, what are the master nodes and the slave nodes, and what are the Kubernetes processes that actually make up the platform mechanism. And finally, we're going to look at a sample configuration that you as a Kubernetes cluster user would use to create those components and configure the cluster to your needs. So let's jump in right into the definition. What is Kubernetes? So Kubernetes is an open source container orchestration framework, which was originally developed by Google. So on the foundation, it manages containers, be it Docker containers or from some other technology, which basically means that Kubernetes helps you manage applications that are made up of hundreds or maybe thousands of containers, and it helps you manage them in different environments, like physical machines, virtual machines, or cloud environments, or even hybrid deployment environments. So what problems does Kubernetes solve, and what are the tasks of a container orchestration tool actually? So to go through this chronologically, the rise of microservices caused an increased usage of container technologies because the containers actually offer the perfect host for small, independent applications like microservices. And the rise of containers and the microservice technology actually resulted in applications that they're now comprised of hundreds or sometimes maybe even thousands of containers. Now, managing those loads of containers across multiple environments using scripts and self-made tools can be really complex and sometimes even impossible. So that specific scenario actually caused the need for having container orchestration technologies. So what those orchestration tools like Kubernetes do is actually guarantee following features. One is high availability. In simple words, high availability means that the application has no downtime, so it's always accessible by the users. A second one is scalability, which means that application has a high performance. It loads fast and the users have a very high response rates from the application. And the third one is disaster recovery, which basically means that if an infrastructure has some problems like data is lost or the servers explode or something bad happens with the server center, the infrastructure has to have some kind of mechanism to back up the data and to restore it to the latest state so that application doesn't actually lose any data. And the containerized application can run from the latest state after the recovery. And all of these are functionalities that container orchestration technologies like Kubernetes offer. So how does the Kubernetes basic architecture actually look like? The Kubernetes cluster is made up with at least one master node, and then connected to it you have a couple of worker nodes, where each node has a kubelet process running on it. And kubelet is actually a Kubernetes process that makes it possible for the cluster to talk to each other, to communicate to each other, and actually execute some tasks on those nodes, like running application processes. Each worker node has Docker containers of different applications deployed on it. So depending on how the workload is distributed, you would have different number of Docker containers running on worker nodes. And worker nodes are where the actual work is happening. So here is where your applications are running. So the question is, what is running on master node? Master node actually runs several Kubernetes processes that are absolutely necessary to run and manage the cluster properly. One of such processes is an API server, which also is a container. An API server is actually the entry point to the Kubernetes cluster. So this is the process which the different Kubernetes clients will talk to, like UI if you're using Kubernetes dashboard, an API if you're using some scripts and automating technologies, and a command line tool. So all of these will talk to the API server. Another process that is running on master node is a controller manager, which basically keeps an overview of what's happening in the cluster, whether something needs to be repaired, or maybe if a container died and it needs to be restarted, etc. And another one is scheduler, which is basically responsible for scheduling containers on different nodes based on the workload and the available server resources on each node. So it's an intelligent process that decides on which worker node the next container should be scheduled on based on the available resources on those worker nodes and the load that that container needs. And another very important component of the whole cluster is actually an etcd key value storage, which basically holds at any time the current state of the Kubernetes cluster. So it has all the configuration data inside and all the status data of each node and each container inside of that node. And the backup and restore that we mentioned previously is actually made from these etcd snapshots, because you can recover the whole cluster state using that etcd snapshot. And last but not least, also a very important component of Kubernetes, which enables those nodes, worker nodes, master nodes, to talk to each other, is the virtual network that spans all the nodes that are part of the cluster. And in simple words, virtual network actually turns all the nodes inside of the cluster into one powerful machine that has the sum of all the resources of individual nodes. One thing to be noted here is that worker nodes, because they actually have most load, because they are running the applications inside of it, usually are much bigger and have more resources because they will be running hundreds of containers inside of them. Whereas master node will be running just a handful of master processes like we see in this diagram, so it doesn't need that many resources. However, as you can imagine, master node is much more important than the individual worker nodes, because if, for example, you lose a master node access, you will not be able to access the cluster anymore. And that means that you absolutely have to have a backup of your master at any time. So in production environments, usually you would have at least 2 masters inside of your Kubernetes cluster. But in more cases, of course, you're going to have multiple masters, where if one master node is down, the cluster continues to function smoothly because you have other masters available. So in this video, I want to give you an overview of the most basic fundamental components of Kubernetes, but just enough to actually get you started using Kubernetes in practice, either as a DevOps engineer or a software developer. Now, Kubernetes has tons of components, but most of the time you're going to be working with just a handful of them. So I'm going to build a case of a simple JavaScript application with a simple database, and I'm going to show you step by step how each component of Kubernetes actually helps you to deploy your application and what is the role of each of those components. So let's start with the basic setup of a worker node, or in Kubernetes terms, a node, which is a simple server, a physical or virtual machine. And the basic component, or the smallest unit of Kubernetes, is a pod. So what pod is basically an abstraction over a container. So if you're familiar with Docker containers or container images, so basically what pod does is it creates this running environment or a layer on top of the container. And the reason is because Kubernetes wants to abstract away the container runtime or container technologies so that you can replace them if you want to, and also because you don't have to directly work with Docker or whatever container technology you use in a Kubernetes. So you only interact with the Kubernetes layer. So we have an application, pod, which is our own application, and that will maybe use a database, pod, with its own container. And this is also an important concept here. Pod is usually meant to run one application container inside of it. You can run multiple containers inside one pod, but usually it's only the case if you have one main application container and a helper container or some side service that has to run inside of that pod. And as you see, this is nothing special. You just have one server and two containers running on it with an abstraction layer on top of it. So now let's see how they communicate with each other in Kubernetes world. So Kubernetes offers out of the box a virtual network, which means that each pod gets its own IP address, not the container. The pod gets the IP address, and each pod can communicate with each other using that IP address, which is an internal IP address. Obviously, it's not the public one. So my application container can communicate with database using the IP address. However, pod components in Kubernetes, also an important concept, are ephemeral, which means that they can die very easily. And when that happens, for example, if I lose a database container because the container crashed, because the application crashed inside, or because the node, the server that I'm running them on, ran out of resources, the pod will die and a new one will get created in its place. And when that happens, it will get assigned a new IP address, which obviously is inconvenient if you are communicating with the database using the IP address, because now you have to adjust it every time pod restarts. And because of that, another component of Kubernetes called service is used. So service is basically a static IP address or permanent IP address that can be attached, so to say, to each pod. So my app will have its own service and database pod will have its own service. And the good thing here is that the life cycles of service and the pod are not connected. So even if the pod dies, the service and its IP address will stay. So you don't have to change that endpoint anymore. So now obviously you would want your application to be accessible through a browser, right? And for this you would have to create an external service. So external service is a service that opens the communication from external sources. But obviously you wouldn't want your database to be open to the public requests. And for that you would create something called an internal service. So this is a type of a service that you specify when creating one. However, if you notice, the URL of the external service is not very practical. So basically what you have is an HTTP protocol with a node IP address, so of the node, not the service, and the port number of the service, which is good for test purposes if you want to test something very fast, but not for the end product. So usually you would want your URL to look like this if you want to talk to your application with a secure protocol and a domain name. And for that, there is another component of Kubernetes called Ingress. So instead of service, the request goes first to Ingress and it does the forwarding then to the service. So now we saw some of the very basic components of Kubernetes. And as you see, this is a very simple setup. We just have one server and a couple of containers running and some services. Nothing really special, where Kubernetes advantages or the actual cool features really come forward, but we're gonna get there step by step. So let's continue. So as we said, pods communicate with each other using a service. So my application will have a database endpoint, let's say called MongoDB service, that it uses to communicate with the database. But where do you configure usually this database URL or endpoint? Usually you would do it in application properties file or as some kind of external environmental variable, but usually it's inside of the built image of the application. So for example, if the endpoint of the service or service name in this case changed to MongoDB, you would have to adjust that URL in the application. So usually you would have to rebuild the application with a new version and you have to push it to the repository, and now you'll have to pull that new image in your pod and restart the whole thing. So a little bit tedious for a small change like database URL. So for that purpose, Kubernetes has a component called config map. So what it does is it's basically your external configuration to your application. So config map would usually contain configuration data like URLs of a database or some other services that you use. And in Kubernetes, you just connect it to the pod so that pod actually gets the data that config map contains. And now if you change the name of the service, the endpoint of the service, you just adjust the config map and that's it. You don't have to build a new image. You don't have to go through this whole cycle. Now, part of the external configuration can also be database username and password, right? Which may also change in the application deployment process. But putting a password or other credentials in a config map in a plain text format would be insecure, even though it's an external configuration. So for this purpose, Kubernetes has another component called secret. So secret is just like config map, but the difference is that it's used to store secret data, credentials, for example, and it's stored not in a plain text format, of course, but in base 64 encoded format. So secret would contain things like credentials. And of course, database user, you could also put in config map, but what's important is the passwords, certificates, things that you don't want other people to have access to would go in the secret. And just like config map, you just connect it to your pod so that pod can actually see those data and read from the secret. You can actually use the data from config map or secret inside of your application pod using, for example, environmental variables, or even as a properties file. So now to review, we've actually looked at almost all mostly used Kubernetes basic components. We've looked at the pod, we've seen how services are used, what is Ingress component useful for, and we've also seen external configuration using config map and secrets. So now let's see another very important concept generally, which is data storage and how it works in Kubernetes. So we have this database pod that our application uses, and it has some data, or it generates some data. With this setup that you see now, if the database container or the pod gets restarted, the data would be gone. And that's problematic and inconvenient, obviously, because you want your database data or log data to be persisted reliably long-term. And the way you can do it in Kubernetes is using another component of Kubernetes called volumes. And how it works is that it basically attaches a physical storage on a hard drive to your pod. And that storage could be either on a local machine, meaning on the same server node where the pod is running, or it could be on a remote storage, meaning outside of the Kubernetes cluster. It could be cloud storage, or it could be your own premise storage, which is not part of the Kubernetes cluster. So you just have an external reference on it. So now when the database pod or container gets restarted, all the data will be there, persisted. It's important to understand the distinction between the Kubernetes cluster and all of its components and the storage. Regardless of whether it's a local or remote storage, think of a storage as an external hard drive plugged into the Kubernetes cluster. Because the point is, Kubernetes cluster explicitly doesn't manage any data persistence, which means that you as a Kubernetes user or an administrator are responsible for backing up the data, replicating and managing it, and making sure that it's kept on a proper hardware, etc. Because it's not taking care of Kubernetes. So now let's see everything is running perfectly and a user can access our application through a browser. Now with this setup, what happens if my application pod dies, right? Crashes, or I have to restart the pod because I built a new container image. Basically, I would have a downtime where a user can reach my application, which is obviously a very bad thing if it happens in production. And this is exactly the advantage of distributed systems and containers. So instead of relying on just one application pod and one database pod, etc., we are replicating everything on multiple servers. So we would have another node where a replica or clone of our application would run, which will also be connected to the service. So remember previously we said the service is like an persistent static IP address with a DNS name, so that you don't have to constantly adjust the endpoint when a pod dies. But service is also a load balancer, which means that the service will actually catch the request and forward it to whichever pod is least busy. So it has both of these functionalities. But in order to create this second replica of the My Application pod, you wouldn't create a second pod, but instead you would define a blueprint for a My Application pod and specify how many replicas of that pod you would like to run. And that component or that blueprint is called deployment, which is another component of Kubernetes. And in practice, you would not be working with pods, or you would not be creating pods. You would be creating deployments, because there you can specify how many replicas, and you can also scale up or scale down number of replicas of pods that you need. So with pod, we said that pod is a layer of abstraction on top of containers, and deployment is another abstraction on top of pods, which makes it more convenient to interact with the pods, replicate them, and do some other configuration. So in practice, you would mostly work with deployments and not with pods. So now if one of the replicas of your application pod would die, the service will forward the requests to another one. So your application would still be accessible for the user. So now you're probably wondering, what about the database pod? Because if the database pod died, your application also wouldn't be accessible. So we need a database replica as well. However, we can't replicate database using a deployment. And the reason for that is because database has a state, which is its data. Meaning that if we have clones or replicas of the database, they would all need to access the same shared data storage. And there you would need some kind of mechanism that manages which pods are currently writing to that storage or which pods are reading from that storage in order to avoid data inconsistencies. And that mechanism, in addition to replicating feature, is offered by another Kubernetes component called Stateful set. So this component is meant specifically for applications like databases. So MySQL, MongoDB, Elasticsearch, or any other stateful applications or databases should be created using stateful sets and not deployments. It's a very important distinction. And stateful set, just like deployment, would take care of replicating the pods and scaling them up or scaling them down, but making sure that database reads and writes are synchronized so that no database inconsistencies are offered. However, I must mention here that deploying database applications using stateful set in Kubernetes cluster can be somewhat tedious. So it's definitely more difficult than working with deployments where you don't have all these challenges. That's why it's also a common practice to host database applications outside of the Kubernetes cluster and just have the deployments or stateless applications that replicate and scale with no problem inside of the Kubernetes cluster and communicate with the external database. So now that we have two replicas of my application pod and two replicas of the database, and they're both load balanced, our setup is more robust, which means that now even if node 1, the whole node server, was actually rebooted or crashed and nothing could run on it, we would still have a second node with application and database pods running on it, and the application would still be accessible by the user until these two replicas get recreated, so you can avoid downtime. So to summarize, we have looked at the most used Kubernetes components. We start with the pods and the services in order to communicate between the pods, and the Ingress component, which is used to route traffic into the cluster. We've also looked at external configuration using config maps and secrets, and data persistence using volumes. And finally, we've looked at pod blueprints with replicating mechanisms like deployments and stateful sets, where stateful set is used specifically for stateful applications like databases. And yes, there are a lot more components that Kubernetes offers, but these are really the core, the basic ones. Just using these core components, you can actually build pretty powerful Kubernetes clusters. So in this video, I'm going to show you what Minikube and kubectl are and how to set them up. So first of all, let's see what is Minikube. If you want to test something on your local environment, or if you want to try something out very quickly, for example, deploying new application or new components, and you want to test it on your local machine, obviously setting up a cluster like this will be pretty difficult, or maybe even impossible if you don't have enough resources like memory and CPU, etc. And exactly for that use case, there's this open source tool that is called a Minikube. So what a Minikube is basically one node cluster where the master processes and the worker processes both run on one node. And this node will have a Docker container runtime pre-installed. So you will be able to run the containers or the pods with containers on this node. And the way it's going to run on your laptop is through a virtual box or some other hypervisor. So basically, Minikube will create a virtual box on your laptop, and the node that you see here, this node, will run in that virtual box. So to summarize, Minikube is a one-node Kubernetes cluster that runs in a virtual box on your laptop, which you can use for testing Kubernetes on your local setup. So now that you've set up a cluster or a mini cluster on your laptop or PC on your local machine, you need some way to interact with a cluster. So you want to create components, configure it, etc. And that's where kubectl comes in the picture. So now that you have this virtual node on your local machine that represents Minikube, you need some way to interact with that cluster. So you need a way to create pods and other Kubernetes components on that node. And the way to do it is using kubectl, which is a command line tool for Kubernetes cluster. So let's see how it actually works. Remember, we said that Minikube runs both master and worker processes. So one of the master processes, called API server, is actually the main entry point into the Kubernetes cluster. So if you want to do anything in the Kubernetes, if you want to configure anything, create any component, you first have to talk to the API server. And the way to talk to the API server is through different clients. So you can have a UI, like a dashboard. You can talk to it using Kubernetes API or a command line tool, which is kubectl. And kubectl is actually the most powerful of all the three clients, because with kubectl you can basically do anything in the Kubernetes that you want. And throughout this video tutorials, we're going to be using kubectl mostly. So once the kubectl submits commands to the API server to create components, delete components, etc., the worker processes on Minikube node will actually make it happen. So they will be actually executing the commands to create the pods, to destroy the pods, to create services, etc. So this is the Minikube setup, and this is how kubectl is used to interact with the cluster. An important thing to note here is that kubectl isn't just for Minikube cluster. If you have a cloud cluster or a hybrid cluster, whatever, kubectl is the tool to use to interact with any type of Kubernetes cluster setup. So that's important to note here. So now that we know what Minikube and kubectl are, let's actually install them to see them in practice. I'm using Mac, so the installation process will probably be easier, but I'm going to put the links to the installation guides in the description so you can actually follow them to install it on your operating system. Just one thing to note here is that Minikube needs a virtualization, because as we mentioned, it's going to run in a virtual box setup or some hypervisor. So you will need to install some type of hypervisor. It could be VirtualBox. I'm going to install a HyperKit, but it's going to be in those step-by-step instructions as well. So I'm going to show you how to install it on a Mac. So I have a Mac OS Mojave, so I'm going to show you how to install Minikube on this macOS version. And I'm going to be using brew to install it. So brew update. And the first thing is that I'm going to install a hypervisor hyperkit. So I'm going to go with the hyperkit. Go ahead and install it. I already had it installed, so with you, if you're doing it for the first time, it might take longer because it has to download all these dependencies and stuff. And now I'm gonna install Minikube. And here's the thing, Minikube has kubectl as a dependency. So when I execute this, it's gonna install kubectl as well. So I don't need to install it separately. So let's see here. Installing dependencies for Minikube, which is Kubernetes CLI. This is kubectl. Again, because I already had it installed before, it still has a local copy of the dependencies. That's why it's pretty fast. It might take longer if you're doing it for the first time. So now that everything is installed, let's actually check the commands. So kubectl command should be working. So I get this list of the commands with kubectl, so it's there, and Minikube should be working as well. And as you see, Minikube comes with this command line tool, which is pretty simple. So with one command, it's gonna bring up the whole Kubernetes cluster in this one node setup, and that you can do stuff with it, and you can just stop it or delete it. It's pretty easy. So now that we have both installed and the commands are there, let's actually create a Minikube Kubernetes cluster. And as you see, there is this start command. Let's actually clear this. So this is how we're gonna start a Kubernetes cluster, Minikube start. And here is where the hypervisor installed comes in. Because since Minikube needs to run in a virtual environment, we're gonna tell Minikube which hypervisor it should use to start a cluster. So for that, we're going to specify an option, which is VM driver. And here I'm going to set the hyperkit that I installed. So I'm telling Minikube, please use hyperkit hypervisor to start this virtual Minikube cluster. So when I execute this, it's going to download some stuff. So again, it may take a little bit longer if you're doing it for the first time. And as I mentioned, Minikube has Docker runtime or Docker daemon pre-installed. So even if you don't have Docker on your machine, it's still gonna work. So you would be able to create containers inside because it already contains Docker, which is a pretty good thing if you don't have Docker already installed. So done, kubectl is now configured to use Minikube, which means the Minikube cluster is set up, and kubectl command, which is meant to interact with the Kubernetes clusters, is also connected with that Minikube cluster. Which means if I do kubectl get nodes, which just gets me a status of the nodes of the Kubernetes cluster, it's gonna tell me that the Minikube node is ready. And as you see, it's the only node and it has a master role because it obviously has to run the master processes. And I can also get the status with Minikube, executing Minikube status. So I see host is running, kubelet, which is a service that actually runs the pods using container runtime, is running. So basically everything is running. And by the way, if you want to see Kubernetes architecture in more detail and to understand how master and worker nodes actually work and what all these processes are, I have a separate video that covers Kubernetes architecture. So you can check it out on this link. And we can also check which version of Kubernetes we have installed. And usually it's going to be the latest version. So with kubectl version, you actually know what the client version of Kubernetes is and what the server version of Kubernetes is. And here we see we're using 1.17, and that's the Kubernetes version that is running in the Minikube cluster. So if you see both client version and server version in the output, it means that Minikube is correctly installed. So from this point on, we're going to be interacting with the Minikube cluster using kubectl command line tool. So Minikube is basically just for the startup and for deleting the cluster, but everything else, configuring, we're going to be doing through kubectl. And all these commands that I executed here, I'm going to put them in a list in the comment section so you can actually copy them. In this video, I'm going to show you some basic kubectl commands and how to create and debug pods in Minikube. So now we have a Minikube cluster and kubectl installed. And once the cluster is set up, you're going to be using kubectl to basically do anything in the cluster, to create components, to get the status, etc. So first thing, we are gonna just get the status of the nodes. So we see that there is one node, which is a master, and everything's gonna run on that node because it's a Minikube. So with kubectl get, I can check the pods, and I don't have any. That's why no resources. I can check the services, kubectl get services, and I just have one default service, and so on. So with this kubectl get, I can list any Kubernetes components. So now since we don't have any pods, we're going to create one. And to create Kubernetes components, there is a kubectl create command. So if I do help on that kubectl create command, I can see available commands for it. So I can create all these components using kubectl create, but there is no pod on the list because in Kubernetes world, the way it works is that the pod is the smallest unit of the Kubernetes cluster, but usually in practice, you're not creating pods or you're not working with the pods directly. There is an abstraction layer over the pods that is called deployment. So this is what we are going to be creating, and that's going to create the pods underneath. And this is a usage of kubectl create deployment. So I need to give a name of the deployment and then provide some options. And the option that is required is the image, because the pod needs to be created based on some image or some container image. So let's actually go ahead and create NGINX deployment. So kubectl create deployment. Let's call it NGINX deployment image equals NGINX. It's just gonna go ahead and download the latest NGINX image from Docker Hub. That's how it's gonna work. So when I execute this, you see deployment NGINX depl created. So now if I do kubectl get deployment, you see that I have one deployment created. I have a status here, which says it's not ready yet. So if I do kubectl get pod, you see that now I have a pod, which has a prefix of the deployment and some random hash here, and it says container creating. So it's not ready yet. So if I do it again, it's running. Another very practical command is kubectl logs, which basically shows you what the application running inside the pod actually logged. So if I do kubectl logs, and I will need the pod name for this, I will get nothing because NGINX didn't log anything. So let's actually create another deployment from MongoDB. So let's call it Mongo deployment. And the image will be Mongo. So let's see, kubectl pod. So now I have the MongoDB deployment creating. So let's go ahead and log that. This status here means that the pod was created, but the container inside the pod isn't running yet. And when I try to log, obviously it tells me there's no container running, so it can show me any logs. So let's get the status again. At this point, if I'm seeing that container isn't starting, I can actually get some additional information by kubectl describe pod and the pod name. which here shows me what state changes happened inside the pod. So it pulled the image, created the container, and started container. So kubectl get pod, it should be running already. So now let's log it. Kubectl logs. And here we see the log output. So it took a little bit, but this is what the MongoDB application container actually logged inside the pod. And obviously, if container has some problems, it's going to help with debugging to see what the application is actually printing. So let's clear that and get the pods again. So another very useful command when debugging, when something is not working or you just want to check what's going on inside the pod, is kubectl exec. So basically what it does is that it gets the terminal of that MongoDB application container. So if I do kubectl exec interactive terminal, that's what IT stands for. I will need the pod name, --bash. So with this command, I get the terminal of the MongoDB application container. And as you see here, I am inside the container of MongoDB as a root user, so I'm in a completely different setting now. And as I said, this is useful in debugging or when you want to test something or try something. You can enter the container or get the terminal and execute some commands inside there. As you notice, when we're creating Kubernetes components like deployment, using kubectl create deployment, you'll have to provide all these options on the command line. So you'll have to say the name, and you'll have to specify the image, and then you have this option 1, option 2, etc. And there could be a lot of things that you want to configure in a deployment or in a pod. And obviously it will be impractical to write that all out on a command line. So because of that, in practice, you would usually work with Kubernetes configuration files, meaning what component you're creating, what the name of the component is, what image is it based off, and any other options. They're all gathered in a configuration file, and you just tell kubectl to execute that configuration file. And the way you do it is using kubectl apply command. And apply basically takes the file, the configuration file as a parameter, and does whatever you have written there. So apply takes an option called -f, that stands for file. And here you would say the name of the file. So this will be the config file.yaml. This is the format that you're usually going to use for configuration files. And this is the command that executes whatever is in that configuration file. So let's actually call the configuration file, NGINX deployment. And let's go ahead and create a very simplistic, super basic NGINX deployment file. So here I'm gonna create that file. So this is the basic configuration for the deployment. So here I'm just specifying what I want to create. I want to create a deployment, the name of the deployment. You can ignore these labels right now. How many replicas of the pods I want to create. And this plug right here, the template and specification, is a blueprint for the pods. So specification for the deployment and specification for a pod. And here we're just saying that we want one container inside of the pod with NGINX image, and we are going to bind that on port 80. So this is going to be our configuration file. And once we have that, we can apply that configuration. So deployment created. So now if I get pod, I see that NGINX deployment pod was created and it's running. And let's also see that deployment was created 52 seconds ago. And now if I wanted to change something in that deployment, I can actually change my local configuration. For example, I wanted 2 replicas instead of 1. I can apply that again. Deployment, NGINX deployment configured. And as you see, the difference here is that Kubernetes can detect if the NGINX deployment doesn't exist yet, it's going to create one. But if it already exists and I apply the configuration file again, it's going to know that it should update it instead of creating a new one. So if I do get deployment, I see this is the old one or the old deployment. And if I do kubectl get pod, I see the old one is still there and a new one got created because I increased the replica count. Which means that with kubectl apply, you can both create and update a component. And obviously you can do kubectl with services, volumes, any other Kubernetes components, just like we did it with the deployment. So to summarize, we've looked at a couple of kubectl commands in this video. We saw how to create a component like deployment. We saw how to get status of pods, deployments, replica sets, etc. We also logged on the console whatever application is writing it to the console in the pod. And we saw how to get a terminal of a running container using kubectl exec. And finally, we saw how to use a Kubernetes configuration file to create and update components using the kubectl apply command. And last but not least, we saw kubectl describe command, which is useful when a container isn't starting in a pod and you want to get some additional troubleshooting information about the pod. In this video, we're going to deploy 2 applications, MongoDB and Mongo Express. And I chose these 2 because it demonstrates really well a typical simple setup of a web application and its database. So you can apply this to any similar setup you have. So let's see how we're going to do this. So first we will create a MongoDB pod. And in order to talk to that pod, we are going to need a service. And we're going to create an internal service, which basically means that no external requests are allowed to the pod. Only components inside the same cluster can talk to it. And that's what we want. Then we're going to create a Mongo Express deployment. One, we're going to need a database URL of MongoDB so that Mongo Express can connect to it. And the second one is credentials, so username and password of the database so that it can authenticate. So the way we can pass this information to Mongo Express deployment is through its deployment configuration file through environmental variables, because that's how the application is configured. So we're going to create a config map that contains database URL, and we're going to create a secret that contains the credentials. And we're going to reference both inside of that deployment file. So once we have that set up, we're going to need Mongo Express to be accessible through a browser. In order to do that, we're going to create an external service that will allow external requests to talk to the pod. So the URL will be HTTP, IP address of the node, and the service port. So with this setup, the request flow will now look like this. So the request comes from the browser, and it goes to the external service of the Mongo Express, which will then forward it to the Mongo Express pod. The pod will then connect to internal service of MongoDB. That's basically the database URL here. And it will forward it then to MongoDB pod, where it will authenticate the request using the credentials. So now let's go and create this whole setup using Kubernetes configuration files. Let's dive right into it and create the whole setup. So first of all, I have a Minikube cluster running. If I do kubectl get all, which basically gets me all the components that are inside the cluster, I only have a default Kubernetes service. So my cluster is empty and I'm starting from scratch. So the first thing that I said we're going to do is create a MongoDB deployment. I usually create it in an editor. So I'm going to go to Visual Studio Code and paste a prepared deployment file there for MongoDB. And this is how it's going to look like. So I have a deployment kind, and I have some metadata. I'm just going to call it MongoDB deployment, labels and selectors. And here in the template, I have a definition or blueprint for pods that this deployment is going to create. And I'm just going to go with one replica. So the container is going to be called MongoDB, and this is the image that I'm going to take. So let's actually go and check out the image configuration for MongoDB. So Mongo, and I see this image here. Let's open this. And basically what I'm looking for is how to use that container, meaning what ports it's going to open and what external configuration it's going to take. So a default port of MongoDB container is 27017. So I'm going to use that. And we are going to use variables, environmental variables, the root username and root password. So basically I can, on the container startup, define the admin username and password. So let's go ahead and configure all of that inside the configuration file. So here below the image of MongoDB, so we're just going to leave the name of the image and it's going to pull the latest one. And that's what we want. So here I'm gonna specify what port I want to expose. So ports, that's the attribute name, and container port. And that's the standard port, so I'm gonna leave it. And below that, I'm gonna specify those two environmental variables. So one is called, let's see what it's called. It's Mongo initdb root username, and here is going to be a value, so we're going to actually leave it blank for now. And the other one is called init root password, and we're going to leave that blank as well, just value. And once we have the values here, we're going to have a complete deployment for MongoDB. This is basically all we need. Now, note that this is a configuration file that is going to be checked into a repository. So usually you wouldn't write admin username and password inside the configuration file. So what we're going to do now is we're going to create a secret from where we will reference the values. So meaning that the secret is going to live in Kubernetes and nobody will have access to it in a Git repository. So we're going to save this incomplete deployment file, first of all. So let's call it Mongo deployment, or let's just call it Mongo YAML and save it here so that we get the syntax highlight. And now, before we apply this configuration, we're going to create the secret where the root username and password will live. So let's create a new file, and I'm going to paste in the configuration of a secret, which is actually pretty simple. So we have a kind secret, then we have a metadata, which again is just simply the name. We're going to call it MongoDB secret. The type opaque is actually a default type, which is the most basic key value secret type. Other types, for example, include TLS certificates, so you can create a secret specifically with the TLS certificate type, and a couple of more types. But mostly you're going to use the default one, and these are the actual contents. So you have the data, and here you have key value pairs, which of course are the names you come up with. So we're going to specify username, or we can actually call it Mongo root username, and we're going to call it Mongo root password. And here's the thing, the values in these key value pairs are not plain text. So when we are creating a secret, the value must be base 64 encoded. So the way you can do that, the simplest way is go to your terminal. So here I'm going to say echo -n, very important option, don't leave it out. Otherwise, it's not going to work. And here I'm going to put a plain text value that I want. So I'm just going to go with just username, whatever. Of course, you can have something more secretive here. And I'm going to base64 encode it. And the value that I get here, I'm going to copy it into the secret configuration as a value. And I'm going to do the same with password. So again, I'm just going to go with simple password. Obviously, you want to have something more secure. And I'm going to copy that as a value here and save it as Mongo secret.yaml. Okay, now we have only written configuration files. We haven't created anything yet in the cluster. So this is just preparation work. And we have to create secret before the deployment if we're going to reference the secret inside of this. So the order of creation matters. Because if I'm creating a deployment that references a secret that doesn't exist yet, I'm going to get an error. So it's not going to start. Since we have our first component, let's actually go ahead and create our secret from a configuration file. So again, I'm going to go to my console. Let's actually clear all this. And I'm going to go into the folder where I'm creating all these configuration files. I called it Kubernetes configuration. And here I have both of my files. So I'm going to do kubectl apply Mongo secret and secret created. So I'm going to do kubectl get secret. And I should see my secret has been created. This is something created by default with a different type. And this is our secret here. So now that we have our secrets, we can reference it inside of our deployment configuration file. So let's go back. And this is how you reference contents, specific key value, data of secret. So instead of value, we're going to say value from. And then I'm going to do secret key ref. Secret key reference, and name is going to be the secret name, so this one here, and key is going to be the key in the data. I want the value of this key value pair, so I want this part of the data, so I'm going to reference it by key. So you don't have to learn it by heart, obviously, all the syntax and attribute names. Important thing here is that you know approximately how to reference it. The actual syntax you can always look up in Google or maybe from previous configuration files. But yeah, this is how you reference it, and we're going to do the same with password. So I'm going to do from, and I'm just going to copy the rest here. Remember, YAML is very strict with the indentation. Here is the same secret, but a different key. So I'm going to use password key here, and that will be it. So now we have the root username and password referenced from the secret and no actual values inside the configuration file, which is good for security because you don't want your credentials in your code repository. Okay, so our deployment file is actually ready. So let's apply that. kubectl apply. And the deployment created, meaning if I do get all, I should see the pod starting up, the deployment, and the replica set. So let's actually check how pod is doing. Container creating. So let's actually watch. It might take some time to create it. If it takes long, and if you want to see whether there's a problem there, you can also do kubectl describe pod and the pod name. So at least we know nothing's wrong there. So we see that it's just pulling the image. So that's what it takes so long. So let's see again, kubectl get pod. And as you see, it's running. So we have MongoDB deployment and the pod, one replica of its pod running. Now the second step is we're going to create an internal service so that other components or other pods can talk to this MongoDB. So let's go ahead and create service configuration. So go back to YAML. And here we can either create a separate YAML configuration file for secret, or we can also include it in the same one. So in YAML, you can actually put multiple documents in one file. So if I put 3 dashes, that's basically a syntax for document separation in YAML. So a new document is starting. So actually I'm gonna put both deployment and service in one configuration file because they usually belong together. So here I'm gonna paste the service configuration. And by the way, I'm gonna put all these configuration files in Git repository and link the repository in the description of this video. So this is a service for MongoDB. Let's go through some of the attributes here. So it's the service kind, just the name. We're gonna call it MongoDB service. Selector, this is an important one because we want this service to connect to the pod, right? And the way to do that is using selector and label. So using this here, the labels that deployment and pod have, service can find the pods that it's gonna attach to. Right, so we have the selector here, and this is an important part where we expose service port. So this is going to be the service port, and this is going to be the container. And since we exposed container port at this address right here, these two have to match. So target port is container or pod port, and this is the service port. And obviously these two here can be different, but I'm going to go with the same port. And that's basically it. That's our service. So I'm going to create the service now. So let's save this file and go back to my console. And I'm going to apply the same file that I applied before to create deployment. So let's see what happens. See both deployment and service configuration, but it's going to know that I haven't changed the deployment. That's what it means here. And a service is created. So if I were to edit both, for example, I can reapply the file and deployment and service can be changed. So I think using local configuration files is a handy way to edit your components. So now let's actually check that our service was created. Get service. And this is our service. And it's listening at port 27017. And I showed it in one of the previous videos, but we can actually also validate that the service is attached to the correct pod. And to do that, I'm gonna do describe service, and I need the service name for this. So here I have the endpoint, which is an IP address of a pod, and the port where the application inside the pod is listening at. So let's actually check that this is the right pod. I mean, we just have one, but still. So if I do get pod, and I want additional output to what I get by default, one of the columns includes the IP address, which is this one right here. So 172.17.06. That's the pod IP address, and this is the port where the application inside the pod is listening at. So everything is set up perfectly. MongoDB deployment and service has been created. And by the way, if you want to see all the components for one application, you can also display them using kubectl get all. That will show all the components, and you can filter them by name. So MongoDB. And here you see the service, deployment, replica set, and the pod. So when you do all, the component type will be the first here. Okay, that's just a side info. So now as the next step, we're gonna create Mongo Express deployment and service, and also an external configuration where we're gonna put the database URL for MongoDB. So let's go ahead and do it. So I'm going to clear that up and go and create a new file for Mongo Express deployment and service. So this is the deployment draft of Mongo Express. Same things here, Mongo Express, that's the name. And here we have the pod definition where the image name is Mongo Express. Let's actually go ahead and check that image as well. We don't need this. This is Mongo Express. And that's the name of the image, Mongo Express. And let's see the same data here. Let's see the port. The Mongo Express application inside the container starts at is 8081. And these are some of the environmental variables. So obviously we need three things for Mongo Express. We need to tell it which database application it should connect to. So obviously we need to tell it the MongoDB address, database address it should connect to, the internal service, and we're gonna need credentials so that MongoDB can authenticate that connection. And the environmental variables to do that is gonna be admin username, admin password, and the MongoDB endpoint will be this here. So these three environmental variables we need. So let's go ahead and use that. So first we're gonna open the port. Again, container, ports. And the reason why you have multiple ports is that inside of the pod, you can actually open multiple ports. So that's gonna be 8081. And now we're gonna add the environmental variables for the connectivity. So the first one is the username. And this is gonna be obviously the same username and password that we defined right here. So what I'm gonna do is I'm just gonna copy them because it's really the same. So the value from, we're gonna read it from the secret that's already there. So I'm gonna paste it here. Second environmental variable is called admin password. And I'm also gonna copy that from here. And the third one is gonna be the database server. And since this is also an external configuration, we could either do value here and we could write the MongoDB server address directly here, or as I showed you in the diagram at the beginning, we can put it in a config map, which is an external configuration so that it's centralized, so it's stored in one place, and also other components can also use it. So for example, if I have two applications that are using MongoDB database, then I can just reference that external configuration here. And if I have to change it at some point, I just change it in one place and nothing else gets updated. So because of that, we're gonna keep this incomplete deployment configuration and we're gonna create the config map, which will contain the MongoDB server address. So I'm gonna create a new file. Let's actually save this incomplete deployment. Let's call it Mongo Express YAML, and we're gonna come back to it later. So save that. Now we need a config map here. So I'm gonna copy the configuration, and this is also pretty simple, just like secret. You have the kind, which is config map, the name, and the same construct. See, just like you saw here, data, which is key value pair, it doesn't have a type because they're just one config map type and that's it. And here you again have key value pairs. So database URL and server name is actually the name of the service. It's as simple as that. So what did we call our service? We called it MongoDB service. So I'm gonna copy the service name and that's gonna be the database server URL. So I'm gonna copy that and let's actually call it Mongo config map for consistency and save it. And just like with secret, the order of execution or creation matters. So I have to have a config map already in the cluster so that I can reference it. So when we're done, I have to create the config map first and then the deployment. So the way that I can reference the config map inside the deployment is very similar to secret. So I'm actually gonna copy the whole thing from secret, put it here. The only thing different here is that instead of secret, I'm gonna say config map. It's all camel case. And obviously the name is going to be config map. That's what we called it, I think. Yes, that's the name. Let's actually copy it. And again, the key is the key in the key value pair here. So let's copy that as well. So now I have our Mongo Express deployment. These are just standard stuff. And this is where the pod blueprint or container configuration exists. We have exposed port 8081. This is the image with the latest tag. And these are the 3 environmental variables that Mongo Express needs to connect and authenticate with MongoDB. So deployment is done, and let's go ahead and create config map first and then Mongo Express deployment. kubectl apply config map, and I'm gonna do kubectl apply Mongo Express, and let's see the pod. So container creating, looks good. So let's see the pod, and it's running. And I actually want to see the logs. So I'm gonna log the Mongo Express. And here you see that Express server started and database connected. So now the final step is to access Mongo Express from a browser. And in order to do that, we are gonna need an external service for Mongo Express. So let's go ahead and create that one as well. So let's clear this output, go back to Visual Code. And as we did last time in the same file as the deployment, I'm gonna create Mongo Express service. Because actually in practice, you never have deployment without the service, so it makes sense to keep them together. And this is Mongo Express external service. And this configuration right now looks exactly same as the MongoDB service configuration. And even the ports are the same. Like here, I have exposed service port at 8081, and target port is where the container port is listening. So how do I make this external service? Is by doing 2 things. So in the specification section, so I'm gonna do it below the selector, I'm gonna put a type. And the type of this external service is load balancer, which I think is a bad name for external service because internal service also acts as a load balancer. So if I had 2 MongoDB pods, the internal service would also load balance the requests coming to these pods. So I think the load balancer type name was chosen not very well because it could be confusing. But what this type load balancer does basically is it accepts external requests by assigning the service an external IP address. So another thing that we're gonna do here to make this service external is right here, we're gonna provide third port. And this is gonna be called node port. And what this is basically is the port where this external IP address will be open. So this will be the port that I'll have to put in the browser to access this service. And this node port actually has a range. And that range is between 30,000 and 32,000 something. So I can not give it the same port as here. As I said, it has to be between that range. So I'm just gonna go with the 30,000. That's the minimum in that range. And that would be it. So this configuration here will create an external service. Let's go ahead and do it, and I will show you exactly how these ports differ from each other. So I'm gonna apply Express. So service created, and if I do get service, I see that MongoDB service that we created previously has a type of cluster IP. And the Mongo Express service that we just created is load balancer, which is the type that we specifically defined. An internal service, we didn't specify any type because cluster IP, which is the same as an internal service type, is default, so you don't have to define it when you're creating internal service. And the difference here is that cluster IP will give the service an internal IP address, which is this one right here. So this is an internal IP address of the service. And load balancer will also give service an internal IP address. But in addition to that, it will also give the service an external IP address where the external requests will be coming from. And here it says pending because we're in Minikube and it works a little bit differently. In a regular Kubernetes setup, here you would also see an actual IP address, a public one. And this is another difference because with internal IP address, you just have port for that IP address. With both internal and external IP addresses, you have ports for both of them. And that's why we had to define third port, which was for the external IP address. As I said, pending means that it doesn't have the external IP address yet. So in Minikube, the way to do that is using the command minikube service, and I'm gonna need the name of the service. So this command will basically assign external service a public IP address. So I'm going to execute this and the browser window will open and I will see my Mongo Express page. So if I go back to the command line, you see that this command here assigned Mongo Express service a URL with a public IP address or with an external IP address and the port, which is what we defined in the node port. So I can basically copy that command, which is the same as this one here, and I get the page for Mongo Express. So now with this setup, the way it's gonna work is that when I make changes here, for example, I'm gonna create a new database, let's call it test DB, whatever, and I'm gonna create a request. What just happened in background is that this request landed with the external service of Mongo Express, which then forwarded it to the Mongo Express pod. And the Mongo Express pod connected to the MongoDB service, an internal service, and MongoDB service then forwarded that request finally to the MongoDB pod. And then all the way back, and we have the changes here. So that's how you deploy a simple application setup in a Kubernetes cluster.
Wow, that was a lot of content. So there we go. Everything that you've learned in this course gives you the full confidence to start using these two technologies, right? Now you can put down on your CV that you know about Docker and Kubernetes. So what I would say is go ahead and try and build something on your own, right? So maybe an existing code that doesn't involve these two technologies, try and write a Dockerfile, running containers, and then try and use Kubernetes to orchestrate your application and see how fun it is, right? And you're going to gain new skills along the way. But if you have any questions, go ahead and join the private Facebook group, and Nana and I will be there, as well as the community, to answer the questions that you have. So Nana, do you want to say anything for our viewers?
I hope you guys learned a lot and got some valuable knowledge from this course that Nelson and I put together for you. If you want to build on that knowledge and learn more advanced Kubernetes related topics or modern DevOps tools, then you can subscribe to my channel where I cover all of these topics. If you want to stay connected or you have any questions regarding Kubernetes and other tools, you can follow me on social media. I would love to see you there. And you can also join Nelson's Facebook group in order to exchange that gained information with others in the community. So thank you for watching and hope to see you in the next video.
Awesome. It was a pleasure teaching you, and this is all for now. I'll catch you on the next one. Assalamu alaikum.